English. I'm Diksha Kaushal, your chemistry master teacher. How are you all, everyone, in the comment section? Can you see me? Can you hear me, everybody? Am I audible to you? Yes. So today we are going to do Biomolecules chapter, a very important chapter and full of structures, right? And I have a very special surprise for you for this lecture. Very special surprise, okay? This is you are going to love it. You are seriously going to love it and you are going to thank me after that. Okay, ma'am, thank you so much. I am sure, I am 100% sure all the students who are present here, everybody, are you ready for that test? Do you want my handwritten notes? Everyone in the chat box, everyone in the chat box, do you want my handwritten notes? Yes. Duration, see, it can go up to 2 to 3 hours, not more than that, okay? Between 2 to 3 hours, right? We are going to cover PYQs, we are going to cover everything in detail. Okay, Pacha, everybody in the chat box. So, ma'am, what is the surprise here? Ma'am, what is the surprise here? Let me show you. This is your surprise, Bacha. This is your surprise. Can you see this? Are you able to see this? Yes, everyone? Yes? Can you see this? So these are the notes for this chapter that you will get, okay? These are the notes for handwritten notes for you, specially for you. So I'll give you those notes. Firstly, starting off with biomolecules. Yes, everyone? Do you want this? Everybody? This is totally free of cost, right? Okay? I'm not gonna study NCERT. Don't worry, I'm covering NCERT for you. Okay, actually in these notes you will find everything. Okay, you will find everything. Just one thing I demand for you. You can just go through NCERT in 15 minutes after that. Have a reading of NCERT. I know the time is really less. So the things that I teach you, everything is NCERT based, okay? I know how the exam pattern is, so everything is going to be NCERT based. Okay, everyone? Yes, perfect. So how you're going to get these notes, everything I'll tell you at the end of this lecture, and trust me, that is totally free of cost, okay? Now we are not going to charge you for these notes, okay? Totally free of cost, you will get these notes, right? Okay, but at the end of the session, I'll tell you how you will get these notes. Okay, bacha? Yes, bacha, yes. Bacha, okay, whether ma'am from, okay. Bacha, right now, I'll give you one by one, I'll give you notes of all the chapters, but one by one, okay? Okay? Yes, everybody? It's a small dose, okay? One by one, you will get that dose of love from me, dose of handwritten notes, right? That dose one by one. Right? Okay, everyone? I want all of you to download the notes and read it. Then you will get the notes for the next chapter. Then download it, read it. Then tell me in the comment section. Yes, ma'am, we have completed this chapter from your notes. Okay, we have completed this chapter. We have completed the NCERT questions. We have completed PYQs, everything. Then I'll give you notes for another chapter. Right? This is how it is going to be. I want all of you to be responsible for this. Right? Okay? Yes. Perfect. So let us start the chapter biomolecules. The very first thing is carbohydrates. So even if you have not studied the chapter, even if you have never studied the chapter, today you will study in detail from the very basic of this chapter. So now what are carbohydrates? So firstly we are going to talk about carbohydrates and proteins and DNA, RNA, all these things, right? Okay. So now what is carbohydrates? Carbohydrates are what optically active polyhydroxy aldehydes or ketones, right? Or the compounds which produce units after hydrolysis, right? They are optically active polyhydroxy. Like if you imagine the glucose has so many OH groups, right? Polyhydroxy, hydroxy means OH group, aldehyde or ketones, right? You will see glucose, fructose, sucrose, all those units. Sometimes you will find aldehyde unit. In some molecules you will find ketone unit, right? Okay, or the compounds which produce such units on hydrolysis, right? Some of the carbohydrates that these are called sugar. Okay, so the sugar that you consume, that is also carbohydrates. Wheat, grains, all these are carbohydrates, right? Most common sugar used in homes is sucrose. That we use in home is sucrose. Okay, that is sucrose. Now the structure of sucrose, everything about sucrose is asked in your exam, right? Whereas the sugar present in milk you say that person is lactose intolerant, because in milk you have lactose, right? The sugar there is lactose. Okay, now what is the structure of lactose? We have to study that. Okay, so all these things are in your syllabus. Next is, they are also called saccharides, right? They are also called saccharides. So now let us discuss the classification. There are monosaccharides, oligosaccharides, polysaccharides. Monosaccharides means they cannot be further hydrolyzed, right? If you hydrolyze this cannot be further divided into any units. Okay, so they cannot be hydrolyzed further to give simpler. For example, glucose. This is a monosaccharide. If you hydrolyze this will not give another unit of any carbohydrate. Okay, it will not produce any other carbohydrate on hydrolysis, right? That is monosaccharides. Oligosaccharides means that on hydrolysis produces 2 units, 3 units or 4 units, right, of monosaccharides, right? Like sucrose. Okay, sucrose on hydrolysis produces glucose and fructose. Though both glucose and fructose are monosaccharides. So sucrose is a oligosaccharide. So we can say it is a di. In oligo also it is disaccharides because it is producing 2 units, right, on hydrolysis. So this is what she is saying. Carbohydrates that yield 2 or 10 units, right? They are called oligosaccharides, right? Polysaccharides, so many units, infinite number of units. So yield a large number of monosaccharides units on hydrolysis, right? So this is the classification of saccharides. Now, firstly, we are going to talk about glucose intermediate. That is a monosaccharide unit. So let us see how monosaccharides are divided. As we said that carbohydrates are polyhydroxy ketones or aldehydes. So on those basis monosaccharides are classified, right? So there are 2 types of monosaccharides. One is having aldehyde group, other is having ketonic group. Okay, one is having aldehyde group, another is having ketonic group. Aldehyde group is that group which is aldose. Okay, this is aldose. This OS is for OS is for carbohydrate. Okay, OS is for carbohydrate, ald means aldehyde. Ald means aldehyde. Let someone ask you, glucose is a aldose or a ketose? Glucose is a aldose or a ketose? Glucose has aldehyde group. So it is a aldose. Glucose is a aldose, right? Those having ketonic group are called ketose. Okay, even on aldose and ketose, they can ask you the question. Okay, what is another name of glucose? Now, for the number of carbon atoms, how it is named, okay, how it is named. If the number of carbon atom in that unit is 3, that will be triose, okay, that will be triose. 3 carbon, os is for carbohydrate, right? Okay, now if I am talking about the aldehyde, that will be aldotriose. If we are talking about a ketone group, like a monosaccharide that has 3 number of carbons and it has a ketonic group, so that will be ketotriose. Okay, so now if they ask you what is the name for glucose? Glucose has 6 number, right? Very good. Glucose has 6 numbers, so that will be hexose, right? And it has aldehyde group, that will be aldohexose. That will be aldohexose, right? That is going to be aldohexose. That is your aldehyde group. It has aldehyde group, and this is the name for glucose, right? This is how it is named on the number of carbon it has and the kind of group it has. Hydroxy, every carbohydrate has a multiple hydroxy groups here, right? Okay, next is we are going to talk about glucose here in detail. So there are many reactions of glucose. Now, you know this is glucose, okay? This is the formula of glucose. Now we don't know how actually it is arranged. How many OH group it has, how many aldehyde group it has. Now we know that it has 5 OH groups. Now we know that it has 1 aldehyde group. But how it was discovered? What are the reactions that actually taken place at that time that led to the formation of that glucose, that defined the structure of glucose? So let us see how it was defined, how we right now know the structure of glucose. So firstly, how glucose was prepared? First is from sucrose, right? Very important, very simple and very important. This is asked so many times in your exams, right? So from glucose, from sucrose, that is cane sugar that we usually eat at our homes, right? So now this sucrose on hydrolysis give one glucose and one fructose. Now you will say, ma'am, the formula of glucose and fructose are same. The formula is same, but there is lots of difference in the structure, right? So we will have to do the glucose and the structure of glucose and the fructose. So now the this is the first preparation, this is the second preparation from starch. Now starch is a polysaccharide, right? This is a polysaccharide. So on hydrolysis, it gives n number of glucose. This is a polysaccharide. This is a disaccharide. It gives two monosaccharides on hydrolysis. So first is from sucrose, second is from starch or cellulose, right? So ma'am, why? What is the reason behind that? We will find that in the structure of sucrose, glucose, fructose, starch. Every structures are very important here, okay? And you need to draw the structures here, right? Okay, so first is the structure of glucose. Now, we right now know that actually the glucose structure is something like this. At the end you have one aldehyde group, you have 4 OH groups here, and the last also, these are secondary, these are 2 degree alcohol, this is 1 degree alcohol. Right now we know this, but how it was defined? So there are so many reactions on this basis, and they can ask you questions on the basis of those reactions, right? Okay, so this was also glucose is an aldohexose and is also known as dextrose. Okay, this is also known as dextrose, right? Next is, it is a monomer of many of the larger components, namely starch. Why it is a monomer? Because on hydrolysis it gives like starch is made up of glucose units, right? That is why it is called the monomer of starch, right? Because starch is formed by combining so many units of glucose, right? Next, it is probably the most abundant organic compound on earth. Yes. Now let us see the structure. Firstly, the molecular formula was found out to be, this is by NMR studies. They find out that the molecular formula is C6H12O6. Yes. Now, second is, we'll go one by one, okay? One by one, all the reactions have some sort of meaning, right? All the reaction have some meaning behind that, okay? So first is, after, they will ask you that in the exam. Now, if you react glucose with HI, what is formed and what does that symbolizes, right? What does that mean? If it is giving N-hexane, what does that mean? That means that it is connected to state chain, 6 carbons are connected here. Right, 6 carbons are connected not via branching but by a simple state chain, right? This is actually we predicted that from the reaction of glucose with HI. We get N-hexane, right? This is the first reaction. Okay, understood? Yes, bacha. Yes, ma'am. Okay, bacha. Okay, I'll go slightly slow. Don't worry. Don't worry. Understood this? Now, this is the structure. Right now, we know just one thing, that glucose has this formula. This is the formula of glucose. We know just this thing. Now, if you react this glucose with HI, it forms N-hexane. Right? Simple N-hexane, normal chain. That means all the carbon atoms are connected, not by any branching, just state chain. Right? Okay? This is the first thing. Hello, bacha. So second thing here is, if we react glucose with ammonium hydroxide, what happens here? If we react glucose with HCl, now we all have done these reactions, you know? We have done these reactions. Do you remember this? That when we have aldehyde or ketone, when we have aldehyde and ketone, if we react this with HCl, what happens here? If we react this with NH4OH, what happens here? Everybody tell me that. Now what happens here? This is actually nothing but NH2Z here, right? So this will be NH4, NH2, H2OH, right? Something like this will be here, right? Okay. Wait. This is NH2OH. Why I'm writing NH4? NH2OH, right? So this is NH2Z. So what happens here? If we have a carbonyl group that reacts with NH2, we get C double bond NZ. This is formed, right? This is formed. Now, if you have a reaction, with HCN, now if you have a reaction of any carbonyl group with HCN, this is negative, this is positive. What will happen here? This H positive, this negative part is going to attack here, and the electrons are going to jump here, and this, and we have this H positive will be here, right? Okay. Now, what will be formed here? You will have C. This is Cn. This is OH. Something like this will be formed, right? This is from aldehyde and ketones. We know that reaction. So now, what we saw here, if we react aldehyde, if we react this glucose with NH2OH, ammonium hydroxide, or HCN, the same reactions happen that we actually thought for aldehyde and ketones. That means there is one aldehydic or ketonic group here. We don't know that is aldehydic or ketonic. That is aldehydic, that can be aldehydic, or that can be ketonic, right? Okay, so this confirms the presence of carbonyl group here, because here you get CN you get this one only, C double bond N OH, okay, and aldehyde also give C double bond N Z. Z here is OH. Z here is OH. This is Z here, right? Okay. So now you get this reaction, that means carbonyl group. Now again this is HCN. You get this cyanohydrin here, right? You get this cyanohydrin CH, CN, OH. Here also you get cyanohydrin CN, OH, right? That means there is presence of carbonyl group here, right? Okay. Yes, bacha, understood? There is no, okay, disaccharide is further, like oligosaccharide is a common term for disaccharide, trisaccharide, tetra, penta, all these things, okay? Oligo means that gives 2 to 10 units, right? Now, if it is giving specifically 2 units, we will say it is oligosaccharide, and in oligo it is a disaccharide, okay? Yes, bacha. Now, next we have this unit. Now, we are reacting this with bromine water. And if you remember this, with bromine water, what happens? With bromine water, this CHO group is oxidized to COH. Now, this means that the carbonyl group that is present here is not ketonic. This is aldehydic group, because ketones do not get oxidized with bromine water, right? So this tells us the presence of aldehydic group, not ketonic group, right? Why? Because ketonic group are not oxidized in presence of bromine water. So here we can guarantee that it has 6 carbons and that it has one aldehydic group only. That carbonyl group here is aldehydic, not ketonic, right? How you will say, how you define that there is aldehydic group, not ketonic? When we reacted this glucose with bromine water, that gave the reaction that CHO group is converted into COH. That means this is definitely aldehydic group, not ketonic group, right? Okay, now we know some sort of things now. Now how to place hydroxy groups here? How many primary alcoholic group here? How many secondary alcoholic group are here? Now we react this glucose with AC twice. Okay, you can say this is acid anhydride, right? We reacted this with acid anhydride. Okay, this is a Cy group here, right? You can simply write it here like this. This is CH3COO twice O. Okay, this is AC twice O, right? Okay, this means AC twice O. Now, if you react acid anhydride with the glucose, what happens here? See this very carefully. See this very carefully. Here we saw that all the OH group here. Here we saw that five OH group were replaced by OAC. OH is replaced by OAC. That means there are alcoholic group present here. Now we don't know what are the alcoholic group that are primary and what are secondary. Right now we have no idea about it. Right? Now we know the anhydride plus alcohol give ester and acid, right? And hydride plus alcohol, esterification reaction, it gives ester plus acid. Now we have the formation of ester here. That is, this OH is replaced by OAC, right? Okay, ester group is present here. That means it has alcoholic group. It has 5 alcoholic group, 5 OH group, 5 hydroxy group here, 5 OH groups are present here. Bacha, they can directly ask you in the exam that how can you determine that it has 5 alcoholic group? You'll have to give this reaction, that this determines that it has 5 alcoholic group. Now, next is, everyone, next is how do we define that how many are primary and how many are secondary? Now, react this glucose with concentrated HNO3. With concentrated HNO3, what you will observe? With concentrated HNO3, what you will observe? With concentrated HNO3, only primary alcohol is oxidized here, right? Only primary alcohol is oxidized, right? And here, you can just write this reaction, and I'll give you something about this reaction also. Now, if you have this very strong oxidizing agent, this secondary group is not oxidized. This primary group is only oxidized, right, to the carboxylic acid group, right? That means there is one primary group here, right? Now, if you have this gluconic acid, okay, this is a gluconic acid. Now, if you have this gluconic acid, they are saying that will be further oxidized, right? If you have this gluconic acid, that was from the oxidation here. Okay, you will see this gluconic acid group here. Okay, gluconic acid is also very important. They can ask you. Okay, what is the difference between glucose and gluconic acid? That is, this is CHO and here it is COH. Now, if you oxidize this gluconic acid, then also you can just oxidize this primary COH group, not this secondary OH group, right? Only primary OH group is oxidized here. That means there is one primary group present here, right, everybody? Right, bacha? So now we know that in glucose there is one aldehyde group, right? There are 5 OH group, out of which one is primary and other 4 are secondary OH groups, right? Now let us see the open structure here. Let us see the open structure. How you will write in Fisher projection, where should be OH and where should be H, okay? How we will write OH and H here? Everybody in the chat box, everybody. So now you have 5 alcoholic group and 1 aldehyde group. The structure of glucose is this, right? Now see this very carefully. See this very carefully. Now, how you write alpha glucose and how you write beta glucose. Firstly, everybody, we just need to know glucose structure and we will write all the other structure with the help of glucose only. With the help of only glucose, you will be able to write all the other structures here, right? You have this glucose structure. This is glucose. How glucose is? Everybody, write doctor. You want to be a doctor? You want to be a doctor? DR, okay? DR doctor, write, okay? Write OH, write OH. We'll see how many OH group are on the right side and what is dextro, what is LEO, everything will be discussed here, right? Now this is the glucose structure, but now I have not defined alpha or beta glucose here, right? Okay, so here this is a primary structure that you must know. This is CHO group and this is COH group, that is primary. In the secondary OH group, that is the main thing here. Where OH should be on the right side, where OH should be on the left side. Now everybody, OH is on the left side only on the third carbon. Only on the third carbon, OH is on the left side, right? Only on the third carbon, everybody write this very carefully, okay? How you will say? Only on the third carbon, you just need to remember these points. Third carbon, OH left, okay? OH left on the third carbon, that's it. You know now the structure of glucose, okay? How you will write it? You have 1, 2, 3, 4, right? This is primary and this is CHO group here, right? Next you have on the 1, 2, 3. Third you have OH here, right? All the OH, other OH are on the right side, right? Then you will write here H group, right? This is H, this is H, this is H, this is H, right? Okay everyone? So now this is the structure of glucose. We will define beta and alpha when we draw the cyclic structures here. Right, everyone? Yes? Okay. Just remember this thing, that on the third carbon you have OH on the left side. That's it for the glucose. You don't need to remember ratta for everything. You don't need to cram anything. Okay. Just remember this one thing. Just remember this one things, and all the points will be added on the notes itself. Okay. I'll add all the points in the notes here. Right, everybody? Yes. Perfect. Now, everyone in the chat box. Next is the stereochemistry. Now, have we done this? What is D and what is L? Everyone, if on the last chiral carbon, you have OH group on the right side. Just remember doctor, okay, doctor. If you have OH on the right side, that means that is capital D. I'm not talking about dextro or levo here. I am talking about the configuration, that is capital D and capital L. It has no relation with the optical isomerism. It has no relation with the optical rotation, right? Whether it's anti-clockwise or clockwise, no relation to small d or small l. Okay, capital D is, that means OH, last chiral carbon, the OH is on the right side. Now everybody tell me whether this is D or this is L. This is the last chiral carbon. The last chiral carbon is the OH is on the right side, so this is capital D. Right? This is capital D glucose. We will say capital D glucose here. Right? Why capital D? Because on the last chiral carbon, the OH is on the right side. Yes, everyone? Okay? Understood this? Perfect. Perfect. No. Dextro doesn't mean D. This D and L. Note this here also. D is not equal to D. Right? L is not equal to this. Right? These are the configurations. These are the configurations. These are the configurations. Right? That means last chiral carbon on right, OH on right. Last chiral carbon, OH on right equals to capital D, right? OH on left equals to capital L, right? Now what is this? These are, this basically means positive, that means clockwise rotation, clockwise. This means negative, that means anti-clockwise, right? What does this mean? This means, this small d and small l means, rotation of plane polarized light. Rotation of plane polarized light. Okay, rotation of plane polarized light towards, to right means small d, to left means this. Okay, right means clockwise. Understood this? Okay, what is the difference between capital D, small d, capital L, small l? Right. Now, next we have the failure of state change structure. Why it was failed? Right? What happened? Why we have to draw the closed structure here? Where we have to draw the ring structure here? What was the use of that? Why it was needed? Because glucose does not show 2,4-DNP test. Okay, 2,4-DNP test, Schiff's base test, NEHSO3 addition product here. Now, glucose is not able to show this. This means that the aldehydic group is not free, right? Because all these tests are shown by the aldehydic group. That means the aldehydic group is not free, right? Okay. Now, this is the pentaacetate. The pentaacetate, you have this. You have pentaacetate means OAC, right? OAC doesn't react with NH2OH to form oxime. Okay, it further does not react with NH2OH to form oxime. That means again this aldehydic group, we have two examples that why we say that the aldehydic group is actually not free in the glucose structure. That means the open chain structure is not true. There is some other structure for glucose. So open chain structure directly form the enzyme and cyclic structure does not. Both the observation indicate absence of free CHO group. There is no free aldehydic group present here, right? Okay, now we have glucose, we have alpha glucose, we have beta glucose. Okay, everyone, we have alpha glucose, we have beta glucose. Now let us see what is alpha, what is beta. Everyone here, firstly let us draw the structures here. Okay, firstly let us draw the structure here. Wait. Okay, so let me tell you how we should draw the structures. Okay, this is, firstly write this one here, right? This is your glucose 1, 2, 3, 4, 5. No. Now this is CHO. This is CH2OH. You have 1, 2, 3, 4. Right? So this is OH, H, OH, OH, H, H, OH, and this is H. This is the glucose here. Now what is the structure? If we open this CHO group here, this C double bond O, C double bond O, H, right? This is the structure. Now what happens here? This O reacts with this one, right? Okay, what happens here? If you see this is the first OH. This is nothing but the carbon here. Okay, the carbon here. This reacted with the OH here. Understood this? Now everybody see this very carefully. See this very carefully how this happens. You will have to draw the cyclic structure here. Now we will draw it with the help of this glucose only. Right? This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Right? Okay. Now I am going to draw it here. Now this is a very this is aldehydic group and this is the OH group. Now these two will react. Okay. These two are going to combine together. Right? And then you will have, this is, the electrons are going to shift here. Okay, the electrons are going to shift here and it is going to form a bond here with this OH, and this bond is going, wait, this is 1. Let me draw this. You have this CH2OH group. Wait, this is CH2OH group here, right? You have this carbon here, right? This carbon having oxygen, right? It will be ringed with this one, right? They will have H here. This is OH, right? Okay, then this is 1, this is 2, this is 3. 1, 2, 3. Yes, we'll have OH, wait. OH, this is H, this is OH. We will define the alpha and beta here only, okay? We'll define the alpha and beta here only. Right? Okay? Wait everyone, wait. Wait. This is the first carbon, this is 6 carbon. What I have done wrong here. The carbon, the electrons are going to shift here. This will be first carbon, this is the OH, and the OH bond is here, right? So the H is going to get bonded with this OH, right? And this O is going to have a bond. See this very carefully, okay? The hydrogen, this H positive is going to link with this one, this hydrogen here. So it is going to form here. Everybody see this very carefully. I am drawing the new bonds with this pink pen, okay? So this is the first carbon here. See this very carefully. This is the first carbon and this is the OH. This O negative is going to get this H positive here and there will be one OH here. There will be one OH here. Right now, and this O is going to form a ring. It is going to form a ring with this one. This O is going to form a ring with this first carbon here. Right? That ring I have shown with the help of this one. This ring I have shown with this one. Okay? This ring I have shown here. Everything else will be same. Everything else will be same here. Everything else will be same here. Right everyone? Okay? Now what I have done here, you have this glucose structure, right? Now how will you draw this new structure, right? This is the alpha one. So how you will draw this? Now this is the fifth carbon, this is the fifth carbon, and this is the first carbon, right? So there will be, how you will simply write it down, there will be this oxygen is going to form a ring with the first one that I have shown with this one, right? There I have shown with this one. Now the electrons are going to jump here. The electrons are going to jump here. There will be O negative, and this is H positive is going to link here, right? There will be OH, right? This OH I have shown here, right? So this is basically this was the first one. This was the first one. This is second. This is third. This is fourth. This is fifth. This is sixth. Yes, all the other structures are same. This is the second one. This is second. This is third, fourth, fifth. Now, what students do wrong here is that they usually write it OH, H, H, OH, right? Because they have seen that in glucose structure you have OH, H, OH, H. Now there must be OH, H, OH, H, right? But there is difference here. Okay, there is the difference here. Yes, everyone, can you draw it yourself? Now, how we define the alpha, right? This is the alpha. This is the beta. Everyone see this carefully. How you write the alpha here? If on the first carbon, the OH is on the right side, that is called alpha. And if on the first carbon, the OH is on the left side, that is called beta. That is called beta. Everything else is same here. Everything else is same here. Right? There is just one difference between the OH on the right side is alpha. OH on the right side at carbon number 1 is alpha. Right? Okay. So I'll write it here only. I will write it here. Okay. I will write it here. That is OH on carbon 1 cyclic structure, cyclic glucose is alpha. OH on C1 right. Okay, this will be right and this will be left. Okay, that is called beta. That is called beta. Right? Okay, so how you are going to draw this alpha and beta, everyone? Okay, just how you will write this down. Okay, you are going to draw this 1, 2, 3, 4 and this is CH2OH. Now, how are you going to memorize this? You have this bond is actually with this carbon number 5. Okay, you have this new bond. Now, all the others are, you have this. This is, suppose this is carbon number 1. This is 1. In the glucose you have, this is OH, this is H, right? And this is, there should be 4 here. There should be one more here, okay? 1, 2, 3, 4, one more here, right? Okay. So we are going to write it like this. This is carbon number 1. This is, in glucose you have at carbon number 2, you have, this is OH. Then carbon number 3 you have H, then OH. Right? And on carbon number 1, draw this, copy this structure. If I can copy this here. If I am able to copy this, yes. Okay. Copy this. I'm not able to copy this. Is it? Okay, I don't know how to copy this. Don't worry. Okay, I'll just write it down again. Okay, this is H. This is H. This is H. Right? Okay. Now the other structure here is, you have this one. This is CH2OH. Right? 1, 2, 3, 4. And draw the O between this. Between first and fifth. Now, just forget about this first one. This is first, second, third. Why I am drawing just one less lines here. But this is for CBSE. This is for NEET. Right? These concepts you must clear these concepts. Right? You have this 4 lines. Okay? This is CH2OH. Right? Okay? This is the Fischer structure here. The O linkage is between first and fifth. This is 1, 2, 3, 4. Okay. I don't know why I am drawing one less. Wait, bacha, wait. This is CH2OH. This is 1, 2, 3, 4, 5. The O bond is here. And now we have, see, apart from this linkage, we have 4 more vertical lines. Just forget about this one vertical line. Otherwise, you have same structure as glucose. That is OH, H, OH. Second carbon OH, third carbon H, then OH. Right? Write it H, OH, and H. Right? Right here H. Now, the next thing is here, that is on the first carbon. If OH on the right side, that is alpha. If that is on the left side, that is beta. Okay, that is the only difference here. That is the only difference here. Now, if you know how to draw the structure of glucose, now this is going to be very easy for you to draw the structure of glucose, then fructose, then maltose, then sucrose, galactose, everything. Right? Okay, understood this? This is how you are going to draw the structures. Are you drawing that with me? Are you able to draw that? Because there is no use if you are not drawing that yourself, okay? If you are not able to draw it yourself, there is no use then. Okay, try to draw that along with me. That is why I am drawing that for you, right? Okay, so this is alpha, this is beta. Now another point that is important for you here, that we have at 30 degrees Celsius we have glucose, and 98 degrees Celsius, the boiling point of water, we have the beta glucose here, right? Okay, now next is the cyclic structure. Now how do you convert this one to this one? You know how to draw this. Now convert the alpha one. This is the alpha one, right? This is the alpha one of first carbon. At first carbon you have OH on the right side. Convert this into the cyclic form, right? So now how you can do this? Just draw a 6-membered ring here. Everybody just draw a 6-membered ring here. Just remember one thing, that on the, everybody, just remember one thing. You have on the first carbon, this is the first carbon, this is the first carbon, right? If that is on the right side, that means, just remember this doctor. Just remember this doctor. That means down, and this means right. This means right. In biomolecules, you just have to remember one thing, that you want to become, that is doctor, right? One thing that you have to become, that is doctor. If there is down, if you have something on the right side in Fisher projection, that will be on the down side. Okay, very simple. Let us see this. Now you have the alpha structure here. Okay, draw the alpha structure. Draw this one line. Everybody with me. Draw this one line CH2OH. Then draw the structure here. Then draw this structure here. This is O, right? And this is the linkage. That is H, right? Now you need to draw 4 lines here. 1, 2, 3, 4. Right? In glucose, you have in the second carbon you have OH. Then you have H. In glucose you have hydrogen on the right side in just carbon number 3, right? So draw it. Just forget about this C1, right? OH, H, and this is OH, right? H, this is OH, and this is H. Now if I am talking about alpha here, if I am talking about the alpha part here, everybody, if I am talking about the alpha part here, you just need to draw this thing, OH on the right side and H on the left side. And H on the left side, this is your structure. This is your structure. So how do you convert it? Okay, how do you convert it? Just draw a 6-membered ring here. Just draw a 6-membered ring here. At one point, just erase this carbon and draw the oxygen here. Then draw the vertical lines. Then draw the vertical line. 1, 2, 3, 4, 5. Okay, then number these lines here. 1, this is going to be the 1, this is 1, this is 2, this is 3, this is 4, this is 5. Okay, number this one also. 1, 2, 3, 4, 5. Right, this is 6. Okay, 5 and this is going to be 6. Right? Okay, understood this? Now, see this thing here. See this thing here. Down, right? Right means down. Right means down. Right means down. That means doctor. That means doctor, you have to remember. Right, first carbon, right OH, that means down. First carbon, right. Second carbon, OH on the right side, that means down. Third carbon, H on the right side, that means H on the down side. This is OH and this is going to be down here. OH on the right side, OH on the down side here. Right? Left side up. Okay, this is hydrogen. This is hydrogen. This is OH and this is H. Right? Now what about this CH2HOH, ma'am? What about this CH2OH? This is not on the right or left side. What about this CH2OH, everyone? What about this CH2OH? Very simple. Just draw the CH2OH here. Okay? This CH2OH, because this has higher molecular mass. So something with higher molecule, if you have nothing on right or left side, something like this, right, on the terminal carbon, what you will do, that the one with higher molecular mass will be on the upper side, okay? So this is with high molecular mass, this is more molecular mass, more molecular weight, so this is on the upside here, okay? So this is going to be on the upside here, that is, this is CH2OH and this is your hydrogen here, right? Very simple to convert this. Yes, bacha, I am confused with beta glucose. Okay, I'll clear that. Firstly, now you know how to convert the alpha. This is the alpha one. Now, let us see the beta one. I'll draw that again. I'll draw the beta one. You draw beta glucose along with me. What you do everybody, just remember 2-3 points here. See, draw one line here, right? Write CH2OH, write CH2OH, and there will be one oxygen linkage between this first carbon and here, right? Draw one oxygen linkage with this one and draw one here hydrogen, right? Have you drawn this? After this, draw 4 vertical lines. 1, 2, 3, 4. Okay. In glucose structure, you know there's one thing that on third carbon you have hydrogen on the left, hydrogen on the right, sorry. You have OH on the left, right? OH on the left. This is the structure of glucose only, right? This one, this carbon number 1, initially did not have any OH group, right? Initially, this carbon number 1 was nothing but C double bond OH, right? After the exchange of hydrogen, it get converted into COH, right? So now this COH defines the alpha and beta structure. Everything else is same in alpha and beta glucose, right? So how you write? Just leave this first position. Just leave the first position here because this first position is nothing but that was actually oxidized, right? The first position was nothing but that was actually reduced. Sorry, it was reduced. The COH group was reduced to COH group, right? Okay, so just leave this first position. Everywhere else, draw same as you have drawn for glucose, simple glucose. Everyone here, are you able to understand this? Draw very simple here. Second you have in glucose just third on the OH is on the left side, just on the third carbon, okay? Third carbon is this one, it is on the left side. Everywhere else it will be on the right side. Leave the first carbon here, right? Have you drawn this? Yes, this was simple. Now, what about the first carbon? If on the first carbon you have alpha, you have OH on the right side, that is alpha. If the OH is on the left side, if the OH is on the left side, so now the OH is on the left side, that is your beta glucose, okay? That is going to be your beta glucose, right? This is the beta glucose here. Now I have drawn the structure of beta glucose. Everyone here, tell me in the comment section, will you be able to draw this structure here, what I have drawn here? Are you able to draw it in a simpler way? Just do this CH2, this is a primary alcohol, right? This primary alcohol. After that, link this carbon number 5 with the oxygen bond here, okay? With the oxygen linkage to the first carbon, right? Have you linked this? After that, draw 4 lines. Now, how to define OH where? In the glucose, this first carbon initially was aldehydic group, right? So it totally depends. Aldehydic group, if it was converted to first carbon has OH on the right side, that is alpha. If it was converted to something like that, the OH group is on the left side, that will be beta glucose. Everything else is same as the open chain structure of glucose. On the second carbon, third carbon, fourth carbon, right? We have just third carbon with OH on the left side, that's it. Okay? Yes, everyone? Perfect? Yes. Okay, so how do you write this? Everyone, how do you write this? How do you convert this into Fischer projection? Draw the 6-membered structure here, then draw the oxygen here, then draw the 1, 2, 3, 4, right? 5 horizontal lines here. Then what is the next thing? That is something that is on the right side will be on the downside in the cyclic structure. Hydrogen on the right side, that is on the downside. OH, right? Then there is hydrogen, then there is OH here, right? Everything else, that is OH, this is hydrogen, OH, this is hydrogen. Now this is having more molecular mass as compared to hydrogen, so that will be on the upside and that this is going to be on the right side. This is beta glucose, right everyone? This is beta glucose. Yes, bacha. Okay, perfect. You guys are drawing perfect, perfect, perfect. So this was about the beta and alpha glucose. If you know how to draw the structures of glucose, you will. This is going to be so easy for you, right? Okay. So this is the epimers. What are epimers? This is if you have epimers are if you have. So epimers are. Let me tell you. Okay. If we're talking about erythros and if we're talking about thyreos, okay, erythros, thyreos. Erythros means the same group is on the same side, right? Thyreos means the same group was on the opposite side, right? That is thyreos, this is erythros, right? So epimers in term used in sugars only, right? That is used in sugars only. And what are anomers? Anomers are cyclic epimers, okay? They are cyclic epimers, right? Okay, two sugar molecules that differ in configuration only at the 10th carbon are CX epimers, right? Okay, on the only on some one carbon, right? They are called the epimers, right? Okay, so what are the anomers? They are nothing but cyclic epimers, right? Now, what are cyclic epimers? Ma'am, what does that mean? Now, alpha and beta are cyclic epimers. See this, okay? I'm going to draw this here, okay? See this here. There is difference between alpha and beta. There is difference between alpha and beta on the one carbon here. On carbon number 1, if OH is on the right side, that is your alpha. If OH is on the left side, that is your beta. So this is going to be, both are going to be epimers of each other. These both are epimers, and because they are cyclic, so I'll say these both are cyclic epimers. That means they are anomers, right? Cyclic epimers are anomers. Okay, so now next we have, okay, right? So these are anomers, right? On the first position, this is H on the upper side, OH on the down. This is OH on the upper, H on the down. These are cyclic epimers, that is anomers. And anomers are epimers, but epimers may not be anomers. What does that mean? Because epimers means that can be open chain and closed chain both, right? And if we specially define that closed chain, that will be anomer, right? So that means anomers can be epimers. Anomers are obviously epimers, they are part of epimers, right? But if something is a epimer, it may or may not be anomer. If it is cyclic, it will be anomer. If it is not cyclic, it will not be an anomer, right? Okay, yes. Now, next is the structure of fructose. Okay, next is the structure of fructose. In fructose, you do not have aldehyde group. We have ketonic group here, right? We have ketonic group here. Now, here we have two primary alcoholic group, right? Here we have two primary OH groups and we have three secondary OH group, and one is the keto group here. Right, one is the keto group here. Now the main thing here comes is that now OH is on the C5 is on the right, D sugar. Now let us see this. What does this mean? Okay, so this is ketohexose. It has ketonic group. It is obtained along with the glucose on hydrolysis of sucrose. It gives 2 units, that is fructose and glucose. Right? It is natural monosaccharides found in fruits, honey, vegetables. It is pure form used as a sweetener. Right? Okay, this is that glucose, right? That is not that is something we energize, okay? That gives us energy. Now this fructose is actually a very natural thing that is formed from fruits, vegetables. We get the fructose from, right? So let us see the structure. You know, the drawing of structure of biomolecule is something very interesting, right? You have this fructose. Now, how you define this? How will you define this? First, you need to know the structure of fructose here. Now, you have the structure of fructose here. What will happen here? This second group, the ketonic group is going to take away the electrons. This is going to link with this OH, right? This is going to link with this OH. There will be OH group. Okay, I'll just draw it for you here. Okay, otherwise it will be difficult for you to understand this, right? Okay, so let us see this. You have this CHOOH group here, and you have this CH2OH group here, right? Other you have this ketonic group here, 1, 2, 3, right? You have 1, 2, 3, right? Okay, this is the primary, this is the primary. You have this H, this is OH, this is H, right? Yes, this is H, OH, OH, sorry, H, OH, OH. This is H, this is H, this is OH. Now, see this, okay? See this. Now here you have 1, 2, 3. This is same as glucose, okay? This is same as glucose. This is 1, 2, 3, 4, 5, 6. What you saw here also, on the third carbon, only for third, you have OH on left. You have OH for left, right? Okay, this is for both glucose and fructose, right? In glucose also what we draw? We draw the structure aldehyde group only on the third carbon. There was OH group on the left side. Same with the fructose, OH group is on the left side only for third carbon, right? This is the first thing, right? No cramming, nothing. For glucose and fructose both are same, right? Okay. Next is, how do we convert this? How do we convert this? Now see this very carefully. Same reaction is going to take place here. Same reaction is going to take place here. Right? Okay. Now see this. I'm drawing this with pink pen. Right? The electrons are going to shift here. The hydrogen here is going to shift here. The hydrogen here is going to shift here. And there will be a new bond. There will be a new bond between this carbon and between this oxygen. There is going to be a new bond formation between the oxygen, the OH group of the fifth carbon, the oxygen of this OH group, and this is going to link with the carbon number 2, because it is going to lose the electron here. Then the H positive is going to shift here, right? The H positive is going to shift here. Now let us see how do we draw the cyclic structure here. How I am going to draw the cyclic structure here. Now draw this one, okay? This is CH2OH group. This is CH2OH group, right? Okay. This is the fifth one. This is H. Combine this OH with this one, right? Okay. Now I'm drawing this in a very rough manner, okay? I have combined this carbon number 2 with this OH, right? And this carbon number 2 has what all? It has one CH2OH group. It has one OH group here. So there is going to be one OH group also. Right? Let us see. For example, I'm not drawing it somewhere. I'm just writing it randomly here. I'm just writing it randomly. This is the carbon number 2. It has one OH group. Right? It has one CH2OH group. It has one linkage with the fifth one. Right? Then we have third carbon, then we have fourth carbon, then we have fifth carbon. This is OH here, hydrogen here, OH here, and H, and this is H. Now have you drawn this structure? Yes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What I have done here? Oh. We have done a mistake here. We have done a mistake here. This is the fifth carbon, right? We are left with just third and fourth, right? This is the OH. We are left with 1, 2, 3, 4, 5, 6, right? And this is OH here. On the fourth carbon, you have OH here. This is H here, and this is OH, and this is H. I have not drawn the permanent structure till I have not drawn it, okay? That is why here we use 5-membered ring, okay? Now, I don't know about this one, whether it should be like this, it should be on the left or right side, right? So this particular thing, the carbon here, is going to define the alpha and beta structure, right? All the other things, this is the first carbon, this is the second carbon, third, fourth, fifth and sixth. Now, there is change in the second carbon. There is change in the second carbon. So, I don't know about the second carbon. What is the configuration of second carbon? If it is on the left side or it is on the right side. Now, this is very important. This is going to define the alpha and beta of the fructose. Right? Okay. Now, see this very carefully. See this very carefully. Now, here, if you have Wait. See this, okay? See this very carefully. Now, we have drawn the structure. Now, if you have the OH group on the right side, this is the OH group on the right side, okay? That is going to be the alpha. If you have OH group on the left side, that is going to be the beta one. Always like this. Now, but ma'am, this CH2OH group should be on the upper side. What you have done here, right? We have not drawn the main particular structure of fructose here. Okay, I have just done the exchange of hydrogen here. That the electrons are going to jump from this pi bond to this oxygen. The hydrogen is going to jump here, and there will be linkage of this second carbon to the oxygen of fifth carbon. I have just drawn that linkage, but actually we will revise this linkage like this, okay? We will revise this linkage something like this, okay? We'll revise this linkage something like this. You have, this is oxygen, this is the bond of oxygen with the fifth carbon, this is CH2OH. Now this primary, right, this is 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. This is first carbon, 1, 2, 3, 4. Okay. 2, 3, 4, 5, 6. Yes. Okay. So now let us see this. Okay. So you know that, just forget about the second carbon here. Just forget about the second carbon here. How you are going to draw this here? In fructose, you have two primary. Okay. First primary is here, second primary, if that second primary carbon CH2OH group is on the left side, okay, and this OH is on the right side, that is going to be the alpha one. This is going to be the alpha fructose here. Everyone remember this one? You have CH2OH group on the left side, OH group on the right side. This is the first carbon, this is the second, and here you have done where there is the change of ketonic to hydroxyl, or there is change of aldehydic to hydroxy, that will define the alpha and beta position here. Okay, you have OH on the right side, this is going to define the alpha here, right? Okay, everything else is same. This first, second, third we have OH on the left side, right? Everything else is same. H here, this is OH here, this is H here. This is going to be the alpha fructose. This is going to be the alpha fructose. And now if you want to write the beta fructose here, how you will write it? Draw the one chain here, write one line, CH2OH. Primary. Oxygen is joined with this fifth carbon. This is the fifth carbon and hydrogen here. Now, you know that if 1, 2, 3, right? Okay. So how I am going to do it here? If the OH group is on the right side, right, and there should be CH2OH group here. This is the first carbon, this is the second carbon. This is the first carbon, this is the second carbon, then third carbon, fourth carbon, fifth carbon, sixth carbon. On the third carbon, in glucose or whether it's fructose, you have OH group always on the left side. Always on the left side. This is hydrogen, this is, otherwise you have OH on the right side. Yes? Okay everyone? Okay? Understood this? Everyone understood this? How we are going to draw this? Yes, this is alpha and this is beta. This is the beta fructose here. Yes? Okay, bacha? Yes, bacha? Done. Okay, bacha? Tell me. Yes? Now, how to draw the structure of fructose, cyclic structure? There we have drawn the 6-membered ring. Here we will draw the 5-membered ring here. Right? Here we will draw the 5-membered ring. Right? 5-membered ring and oxygen. All these things I'll just teach you here. Okay? Now, if you're talking about the alpha fructose here. This is the alpha fructose. Right? This is oxygen. This is CH. Right? This is CH2OH. If I talk about the alpha, there should be OH here. There should be CH2OH here. Right, this is 1, 2, this is third, fourth, fifth, sixth, right? Okay, so this is the third one, 1, 2, third, OH on the left side and this OH on the right side. Okay, OH on the right side. You have this as the fructose. This is the alpha fructose. Alpha fructose, how to draw this? Just draw a 5-membered ring here. Draw a 5-membered ring. right? Draw a 5-membered ring. You have drawn the 5-membered ring, right? Replace this one carbon with oxygen. That is this one. Okay? Understood? Draw 1, 2, 3, 4 vertical lines here. Draw vertical lines here. Yes. After that, always remember down means right side. Okay? Down means right side. That is doctor. That is doctor. So now if you have right side, that is, this is 1, this is 2, this is 3, 4, 5, and this is the 6th one. Okay? If you want to draw it here, so this will the second one. Okay? So the first is going to be on the upper side, that is CH2OH, right? The left one is going to be on the, wait, if I draw this as the second one, the second, third, fourth, fifth, right? Okay, so now how I am going to draw it? Everybody, on the second carbon, you have the OH group on the right side. Right side means down. So OH here, this is CH2OH, right? Then you have hydrogen on the right side, then you have OH on the right side, right? Talking about the 5th one, you have the maximum, the more molecular weight will be of this one. This has more molecular weight. Molecular weight is more. So this is CH2OH, right? And this is hydrogen. Everything else is, this is hydrogen, this is OH. Yes, everyone? Okay. How you will get plus and minus? Plus and minus is defined experimentally. This you cannot predict with the help of any structure, right? Just you know one thing, that experimentally fructose is levorotatory and glucose is dextrorotatory. That is plus and this is minus, right? Okay, this is experimentally drawn. Like this is the structure of alpha fructose, right? Ring structure. Now this is here. This is the structure of wheat. This is the structure of beta 1. Yes, this is the structure of beta 1. Okay. Wait. This is the structure of beta 1. Right, this is the structure of beta glucose. Right, here also you have on the third position. Right, now just this is second, this is third. I'll draw it for you. Okay, actually I think drawing it for you is much easier than explaining already written notes here. Right, okay, so you have this one. This is oxygen. This oxygen is linked with this 5th carbon with 1 hydrogen, and this is a primary OH group here. Right? Draw here. This is going to be the 1, 2, 3, 4, 5, 6. Okay? This is 1, 2, 3, 4, 5, 6. The OH on the left side defines the beta fructose here, and this is going to be CH2OH. This is 1st carbon, 2nd carbon. Okay, this is the 1st carbon here. This is the 1st carbon. This is the 2nd carbon, 3rd carbon, 4th carbon, 5th carbon, 6th carbon. Right? Now you have the 3rd carbon, the OH is on the left side. 4th carbon, the OH is on the right side. This is H, this is H. Right? Okay, everyone? Yes? Just draw it. Draw the 5-membered ring here. Draw the 5-membered ring. Draw one oxygen here. Then vertical lines here. Then you know that this is going to be the first, right? 1st carbon is on the right side. That means it is in down, right? This is CH2OH. This is the 1st carbon. This is 2nd, 3rd, 4th, 5th position, right? Then on the 3rd carbon, H is on the downside. 4th carbon, OH is on the downside. 5th carbon, you have CH2OH, that is having more molecular mass, that is CH2OH, and this is hydrogen. This is how you draw the cyclic structure. Now, if you know the cyclic structures of glucose and fructose, of beta glucose, beta fructose, beta alpha glucose, alpha fructose, all these things, right? If you know these 4 structures, you will be able to draw the structure of sucrose, the structure of maltose, lactose, everything, galactose, everything here, right? Okay. Understood? Yes, perfect. Okay, bacha. Everyone here understood this? Okay. Now what is this ring? Okay. The ring in glucose is pyranose ring, and the ring in fructose is furan ring. Okay. So that is why this is called furanose ring. Okay. And the ring in glucose is pyranose ring. That 6-membered ring was pyranose ring. And this was actually derived from furan. Right, so that is why it is called furanose ring. Right, the ring is formed, 5-membered ring is named as furanose. Furan is a 5-membered ring, right? You know that this is a heterocyclic compound, right? Okay. Now everybody here, is there any problem in drawing the structure of alpha, beta, glucose and fructose? Right, everyone here? Everybody, I will summarize that for you. I will just summarize that for you. What we have done till now. Whether it's glucose, whether it's glucose or it's fructose. Usually the main problem that students face here is, ma'am, where should we do the right side fructose, how should we draw the right side OH group? How can we recall that? How can we remember that? Always remember, in glucose and fructose, open chain structure, you have 3rd carbon OH on left side. That's it. In glucose or whether it's fructose. And if we talk about alpha, then if we talk about cyclic structure, first carbon on glucose and second carbon on fructose. Define the alpha beta here, right? If we're talking about the first carbon on glucose, if it is on the OH on right, if OH on right, that is alpha. If OH on left, if OH on right, that is alpha, right? That is alpha. If on the second carbon, OH on right, that defines the alpha for fructose here. Yes, everyone? Perfect. Okay, bacha, I'll take the session till I complete the chapter here. Full chapter here. I'm going to complete today. Right? Okay? Right? Okay, bacha? No issues in sucrose, no issues in glucose and fructose. Yes, perfect. So now let us draw the structure of glucose, sucrose and all that. Here you just need to remember the glycosidic linkages. That's it. Okay. Now if you know how to draw the structure of glucose and fructose, you just need to remember the glycosidic linkages. Right? 1, 2, 3, 4 carbon here. That's it. Okay. Now let us see. What about sucrose? Sucrose is dextrorotatory. Now why this is dextrorotatory? Now why sucrose is dextro? But after hydrolysis you will see very important question that is asked. Very important question. Sucrose is dextrorotatory. If we talk about this is sucrose, it gives rise to glucose and it gives rise to fructose. Right? Now glucose is positive, that is dextrorotatory. This is levorotatory. This is also dextrorotatory. Now what happens here? After hydrolysis, right, if it gives positive and negative, dextro and levo both. But the fructose here is more as compared to the dextrorotatory glucose here. That is why the sign after hydrolysis of sucrose changes from positive to negative. We talk about the overall rotation here. The overall rotation in this case is levorotatory. That is why it is called invert sugar. That is why sugar is called invert sugar. Right? Okay. So hydrolysis this bring about a change in the size of sign of rotation, that is from positive to negative, and the product named is called invert sugar. That is called invert sugar. Yes, perfect. Next we have lactose. Now let us talk about lactose here. Yes, firstly let us talk about the sucrose here. Right? What are the linkages in sucrose? Remember, you just need to remember this one line. That's it. If you know the structure of glucose, fructose, you just need to remember this one line. That is, glycosidic linkage is between C1 of alpha D glucose. Draw the alpha D glucose here. Draw alpha D glucose here. This is the C1. This is the 1 here. This is 1 here. Okay. This is the first. This is first. This is 1. This is 2. This is 3, 4, and this is 5. This is 6. So there will be linkage of C1 of 1 alpha D glucose and with C2 of beta D from. fructose. Draw the structure of beta D fructose. Right? If we talk about the C2 here, just invert this, okay? Just invert this. This is going to be 1 and this is going to be 2. Right? Okay, they are talking about beta 2, right? Okay, so this is going to be opposite here. Right? This is going to be opposite here. This is the first one, beta. Beta means they are talking about, beta means OH on the right side, that means on the down side. Oh, that is alpha. OH on the left side. Beta means OH is on the left side. That means beta means the OH is on the left side, right? On the left side, OH on the left side. Left means it is going to be on the upside. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. This is beta, right? So how they are going to combine together with this carbon number 2 and this carbon number 1. Okay, just write these, draw these two structures here. Just draw these two structures here, everyone. Right? Draw this one structure here as it is. Draw this second structure in an opposite way. In an opposite way. Right? Just draw this second structure here. Everyone here, just draw this structure. This CH2OH. Wait. There is something wrong here. This should be C. 1, 2, 3, 4. C2 or beta D glucose. This is not C2. This is 1, 2, 3, 4, 5. Okay. So everyone here, listen to this very carefully. Ma'am, can you draw and show? Okay, I can draw and show to you. Okay, listen to this very carefully. They have actually drawn it something like this, okay? Okay. They have taken the counting from this side, okay? In this case, they have taken the counting like this. 1, 2, 3, 4. Okay? They have taken the counting like this. That is, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Right? They have taken the counting like this. Right? So I'll just draw it for you. I'll just draw, this is... I'll just draw it for you, okay? It is going to take time, but I'll draw it for you. Right? You have this alpha, right? Alpha D. Now you have alpha glucose here. This is the alpha one, right? Just draw this 5-membered ring here. I'm not going to draw all the structures here, right? Okay? So this is the oxygen part here. This is the oxygen, right? I'm just going to draw the second structure, this second one here. Right, this is alpha D. This is alpha D. Alpha means you have OH on the downside. Okay, OH is on the downside, and here you have H here. Right? Okay, this is the alpha. Right? Everything else is going to be the same. Everything else is going to be the same. Okay. Next you have, this is beta fructose. Right? This is beta fructose. Now you have this one, 1, 2, 3, 4. This is the oxygen part here. If we talk about, here you have CH2 OH linkage, right? Okay, everyone here. It should be, here they have written the wrong part here. Okay, let me write this. This should be hydrogen here, right? Okay, there should be hydrogen here. This is actually wrong thing that they have drawn here, right? Okay, just see how I am drawing, okay? Just see how I am drawing this. Okay, you have drawn the alpha D glucose here. At alpha D, there is just, this is the first position, second position, third position, fourth position, fifth position, right? Or this is the alpha position, this is beta. On alpha, you have a second position. On second position, you have OH on the right side, third position OH on the left side, OH on the right side, and then you have CH2OH group here, right? This is H, this is going to be H here, H here, H here, H here. This is your alpha D glucose. Now you have this one, that is CH2OH on this side, right? I am drawing this opposite, okay? I am drawing this totally opposite. You also draw this like this, okay? This is the first carbon. If I take this as the first, see this very carefully. This is the first carbon. First carbon, you know that is CH2OH. If I am talking about beta, that means OH should be on the second carbon. OH on the second carbon should be on the left side. Should be on the left side, that means it should be up, right? So there should be OH here. There should be OH here, right? There should be OH here, right? Okay. OH on the left side, that should be up. This is CH2OH. This is CH2OH. 1, 2. This is 1, 2. Then this is 3. This is 4. This is 5. And you have CH2OH group here. That is hydrogen here. Third group, this is OH on the upside. Then you have H here and OH here. This is that we have drawn here. This is that we have drawn here. Right? So now what they have done here, everybody listen to this very carefully. Now, this is the second linkage here. This is the first linkage here. What will happen? H from here and the OH from here. Okay? They will take out the hydrogen and oxygen from this side. Okay? So there will be formation of new bond. Right? There will be formation of new bond here. Okay? Wait, just give me a minute. Just give me a minute. Something is wrong here. Something is wrong here. Just give me a minute. Yes. Yes. Just I am going to delete this page. Okay, I am going to delete this page because this is actually they're not shown the right structure here. So I am deleting that page. Okay. Do you see this? How to convert this? Okay. How I am going to draw this? Okay. This is the first carbon. This is the second carbon that I have taken. This is the first carbon and this is the second carbon. Right. This is the first, second, third, fourth, fifth, sixth. I have not drawn it 1, 2, 3, 4. I have drawn it 1, 2, 3, 4. 1, 2, 3, 4. Why? Because I have to eliminate water here. Okay. I have to eliminate water here. How I am going to eliminate this? This is the OH. This is the OH here. Right. Hydrogen from this side. Oxygen from this side. That's it. Okay. Just link this accordingly. Just link this accordingly. What we are going to have here. Everybody, what we are going to have here. Just link this. Here I am erasing this one, erasing this one, erasing this one. Okay. You are going to have this kind of linkage here. You are going to have this kind of linkage here. Right. You are going to have this kind of linkage here. Okay. You are going to have this kind of linkage here. Right. Either you can draw it something like this or you can simply draw it something like this. Or you can simply draw it something like this. Oxygen and this is CH2OH. Right. That's totally your choice. In some books, this is also written as something like this, okay? This is also written something like this, okay? This is O, this is O, this is this. You will see this is CH2OH. In some books, you will see this is, they have drawn CH2OH and this is oxygen. This is oxygen here and the oxygen from this one. Okay, basically what you need to remember here, that this is the second carbon, this is the first carbon, this is the first carbon and this is the second carbon. So there is glycosidic linkage between 1 alpha and 1 alpha glucose, 1 alpha glucose, 2 beta fructose, right? 2 beta fructose. And in some books you will see, in some books also, I'll just draw that for you because there's so many confusion related to this. In some books also what you will see, okay? in some books what you are going to see, in some books what you are going to see, in some books you are going to see a very different structure. In some books you are going to see a very different structure, that is this one, okay. What the structure will be like, okay, what the structure is going to be, okay, how the structure is going to be. They will write this is 2, 3, okay. They will draw a new structure, that is they will draw something like this. This is your beta, right? If they draw beta as this is 1, this is 2, this is 3, this is 4. Now if they draw this as the first one, now at beta you have OH, on the left side, that means on the upside, okay. This is the OH, this is CH2OH, this is first and this is second, this is third, this is fourth, this is fifth, right? Sixth, this is sixth, right? This is hydrogen. On the third you have OH on the left side, that is upside. This is hydrogen, this is OH and this is HA. Now in some books what they will do, they'll just draw the linkage like this, okay. They will draw the linkage something like this. In some books they are going to draw the linkage like this. O, and this is the O part. Why? Because earlier you had OH part here, hydrogen eliminates from this side, OH eliminates from this side, then you have the linkage of O, right? So these are actually the structures, right? So this is also the structure. In some books you will see this is also the structure. So in this way they have written 1, 2, 3, 4, 5, 6. This can be complicated for you, right? Because you are used to drawing fructose like this, that is 1, 2, 3, 4. So I would highly advise you not to follow this one, right? If you have written something like this, that is also correct, right? This is also correct. Either follow this one, but in this way you will have to draw the fructose as 1, 2, 3, 4, 5, 6, right? Not 1, 2, 3, 4, 5, 6. Accordingly, you can't just cram things and put that, right? Always remember there is C1 and C2. C1 alpha, C2 beta, okay? So if you have to draw this is OH, this is H, eliminate the water here, you will get this structure. If you are writing this one, this is the 1, 2, 3, 4 part, this is 1, 2, 3, 4 part. In that case, you can also draw it like this. You can also draw it like this. So I guess this is much easier for you. Yes? Okay? Okay everyone? The structure is correct. Yes. No, both the structures are correct. Even this is correct and this is also the correct structure. Okay. Don't draw 1, 2, 3, 4 from this side if you are drawing this structure. If you are combining the structures like this, do not draw 1, 2, 3 from this side. Draw 1, 2, 3 from this side. If you are combining the structures like this, draw the 1, 2, 3, 4 structures like this, like that you are used to of drawing, right? Okay everyone? Yes? Okay. Everyone in the comment section, you will see different books. This structure of sucrose is written very differently. In some books you will see this structure. In some books you will see this structure. Both the structures are correct. Right, both the structures are correct. It just depends how you are writing the fructose here. Right, okay, everybody in the comment section. Yes. Everybody in the comment section. Understood this? Yes, bacha. Now let us see the lactose. Lactose is very simple. Lactose, because here you do not have C1, C2. Right, here you have C1 and C4. So C1 and C4 is not difficult for you. C1 and C4 is not difficult. Okay. So now see this. You have this galactose, right? Galactose, and this is beta glucose. Right? This is the first position, right? And here you have this the first position. This is the first, second, third and fourth position here. You have one position here. So this Earlier it would be, there would be OH here, this is OH here, there was one OH here, there was one OH here. So OH eliminates from this side, hydrogen eliminates from this side, and hence you have the formation of new oxygen here, right? Okay, you have the formation of oxygen linkage. This is easier because you don't have linkage. When there is linkage of C1 and C2, then you have to see, because in this side you will get C4 structure. Either you will have to invert this structure or you'll have to draw the structure below, right? That is your choice. But in this case, there is nothing like that. This is C1, this is C4, just eliminate water and draw the new structure, right? Okay, done? Yes, bacha. Okay, there is linkage between C1 of galactose and C2 or C4 of glucose. That's it. Yes. Now, this is found in milk, sugar and everything. This is found in milk, sugar. It is supposed to be beta-D galactose and beta-D glucose, right? Okay, free aldehyde group may be produced C1 of glucose unit. Hence, it is also a reducing sugar, right? This is also a reducing sugar. All monosaccharides are reducing sugar, right? What about the disaccharides? So, sucrose is not a reducing sugar. Okay, this is a reducing sugar. This is a reducing sugar. Now, next we have maltose. Maltose, you have two linkages, that is again from C1 and this is from C4. Now, if you have again linkage of C1 of one, that is one of this, and C4 of this one, then again it is easier for you. You have C1 of alpha D glucose and C4 of another alpha D glucose here, right? Now you have, this is the first position, this is the first position, this is the first, and this is the first, second, third and fourth position. Just eliminate water from this side, eliminate water and draw the structure accordingly. Yes, bacha, just draw the structure accordingly. Yes, okay everybody. Yes, bacha, the eliminate water is eliminated like this. OH of this and H of this. Then you have new oxygen linkage here, that is shown this side. Okay, that is glycosidic linkages. Right? Okay. Okay. Okay, bacha. Yes. Next we have polysaccharides. Now everybody, any problem, let us summarize this. Everybody in the chat box, let us summarize this, what we have done. Okay, we have done three things, that is sucrose, we have done lactose, we have done maltose. Okay, we have done maltose. Here just you need to remember this one, that alpha 1 linkage of glucose, alpha 1 glucose plus beta 2 fructose. Okay, plus beta 2 fructose. This is the first linkage. Second is lactose is galactose and glucose. Okay, this is from galactose and glucose. Right, this is C1, this is alpha 1 plus this is alpha 4. Right, okay, this is both glucose, alpha 1 glucose plus alpha 1 glucose, right? Okay, we have done these three things as sucrose, maltose and lactose, right? Okay, here this one, sucrose one is something that usually students do wrong, because there is alpha 1 and beta 2. They usually what they do, they want to eliminate, they will eliminate alpha 1 and beta 4, right? This is beta 2. Okay, I am going to highlight this. This is beta 2. This is not beta 4. Okay, this is beta 2. Yes, bacha. Okay, reducing sugar are that where tolerance test and all those tests are followed, Fehling test is followed. Non-reducing sugar are where these tests are not followed. Okay, understood? Next we have amylose. Everyone, till now, any problem in drawing the structures? Will you be able to draw the structure of glucose, galactose, fructose? Yes, bacha. Everybody, any problem here? Any problem here? This is the structure of maltose, right? Okay, glucose and this is the structure of glucose and glucose. This is maltose. Then we have between lactose, that is galactose and glucose, C1 and C4, right? Okay, bacha. Any problem till now? Any problem, bacha? Any problem? Any problem? Yes, everybody. Everybody, we are going to jump to the next section. Now we are going to do most of the theory part here. Right? Okay. Everyone here, are you able to understand? Everyone in the comment section, tell me structure of structure of galactose is same, okay? It is same. I think I forgot to tell you that, okay? I'll write it here. Structure of galactose is same as glucose. Galactose is same as glucose, except at C4 you have OH on left side, okay? How? See this? You have this is let us draw the structure of glucose here, okay? This is the structure of glucose, right? Let us draw the structure of benzene ring, okay? This will be one oxygen here, okay? Not benzene, this is cyclohexane, right? Okay, then oxygen here, then draw the vertical lines here, right? This is going to be the first position, everybody. This is the first, this is second, this is third, this is fourth, this is fifth. Now, see this very carefully. Now, if we talk about the fifth position, always we have CH2OH group on above and hydrogen on below. Third position, whether it's glucose, fructose, anything, you have OH on the left side. Left side means up. Left means up, right? Okay. Add galactose. You have, everybody, add galactose. You have, wait. OH on the right side, there will be OH on the left side, there will be OH here, right? On the first side, on the first carbon, you have this H and OH, right? This will be on the right. If you're talking about the alpha position, alpha means OH is on the right side, right means down here, right? Second, you have OH on the right side, down here. This is hydrogen, and this is your alpha. This is alpha galactose. Okay, this is alpha galactose, right? Okay, this is alpha galactose. In glucose, you have this OH group on down and this the H group above. Okay, you can see this here, right? This is the galactose structure. Fourth position, OH is on the left side, that is above. Fourth position, OH is on the right side. Okay, this would be down, this would be above, right? There is elimination of water here and you have this linkage. Yes, everyone, there is just one difference here. Okay? Okay, bacha. At the end, this is very simple. You just need to, just recall few things. You don't need to recall all the structures here. Right? You just need to recall few things from the structures here. Now, next we have amylose, okay? Next we have amylose. So the main famous is, what is the difference between amylose and amylopectin? So what is amylose? Amylose is actually polysaccharides. These are polysaccharides that give so many units of monosaccharides, right? So there's so many linkages. So basically the linkages are from alpha D glucose, that is the C1 of alpha D glucose, and by C4 of alpha D glucose here, right? You have two structures, right? This is basically the polymer of maltose, you can say. Okay, this is basically nothing but the polymer. If you talk about this, just one linkage. If there is just one linkage between alpha glucose, alpha 1 position and alpha 4 position, that is called maltose. If there are so many linkages between one molecule of glucose and the fourth molecule of and another molecule of glucose at the fourth position here, right? So in this case you will get this kind of structure. Okay, wait, this is not right. Again I have to, this is not right. This is H, right? Okay. Yes. Okay. Right, just one, that is C1 of glucose and C4 of another glucose. There are so many linkages here. In amylopectin, there is also branching. Okay, in amylopectin you have branching. There is one C1 and C4 glycosidic linkages between two molecules or more molecules of alpha D glucose, but there is also another branching that is between C1 and C5, right? That means between C1 and C6 glycosidic linkage, right? This is between C1 and C6 glycosidic linkage. So this question is asked so many times that what is the difference between amylose and amylopectin? Amylose is just linear structure, like where you have C1 and C4 linkages. Amylopectin, in addition to C1 and C4 linkages, you have C1 and C6 linkages also. That means there is additional branching here. Okay, otherwise monomer is same. The monomer is same. Yes, perfect. Now let us see what is glycogen. Okay, what is glycogen? So all these questions are asked. Okay, carbohydrates stored in animal body is called glycogen. That is stored in the animal body, known as animal starch because its structure is similar to amylopectin, rather more highly branched. Okay, this is also asked what is the difference between glycogen and amylopectin. Amylose, there is no branching. Amylopectin, there is branching between C1 and C6. Glycogen is an animal carbohydrate. Here we have branching in a large extent. We have such large amount of branching here. Okay, that is the difference between amylopectin and glycogen. Okay, now present in liver, muscles, brain. When the body needs glucose, this is very important point. Okay, especially for you. When the body needs glucose, now how it is produced? Enzymes break the glycogen that is stored in our body down to glucose. Right? Glycogen is stored in our body, right? Whenever we are out of, like we are not eating something. So how we get energy? We are not just like, okay, we are just starving and we are not eating something and we are dead. That thing doesn't happen. Okay, we have glycogen stored in our body that is converted into glucose when we need it, right? Okay, so now this is like highly branched structure of amylopectin, right? Next we have cellulose. Now what is cellulose? This is also asked. This is a plant. This occurs exclusively in plants and most abundant organic substance in plant kingdom, right? It is predominant consistent of cell wall, plant cell, all these things you have studied in biology, right? So basically what linkages it has? It has only alpha D glucose unit which are joined by glycosidic linkages. Okay, it has alpha D glucose unit joined by glycosidic linkages between C1 and C4 of the next glucose, right? Okay, but this is a plant tissue. This is a plant tissue, right? This is not animal, right? This is plant tissue, right? Next we have amino acids. Now we have done carbohydrates, we have done glucose, we have done fructose, we have done galactose, right? Glucose has aldehyde group, fructose has ketonic group, galactose is nothing but it is same like glucose, it just differs with C4 position. After that we draw sucrose, fructose, sucrose, maltose and lactose from the monosaccharides, right? You have to remember sucrose have which glycosidic linkage, right? Maltose and then lactose glycosidic linkages, and then eliminate water and link them with the oxygen linkage, right? That is the second thing that we have done. Third, we have done polysaccharides, where we have done what is starch, what is cellulose, what is amylose, what is amylopectin, what is glycogen, right? Okay, yes. Very good, Nancy, very good. Yes, that gives red color with the iodine, right? Okay, so now that is amino acids. Now let us talk about amino acids. Now amino acids have two units, right? It has one basic unit, it one has one acidic unit. This is a basic unit, this is the acidic unit. So depending upon the how many number of basic unit it has. Suppose we have 4 NH2 units and 2 COH units. That will be basic amino acid. If you have more COH unit, that will be acidic amino acids. If the number of NH2 and COH are same, that will be neutral amino acid, right? Okay, depending upon the relative position with respect to carboxyl, they are defined as alpha, beta, gamma, right? So how it is defined? This is the COH, right? This is the alpha position here. So the NH group is at the alpha position to this carboxylic group, right? This is the alpha carbon, it is linked to the alpha carbon, right? The NH2 group is linked to the alpha carbon, that is alpha amino acid. If we have something like this, that is COH, and you have C, this is NH2, right? That is alpha, this is beta. Now this is beta amino acid, This is beta amino acid, right? Okay, this is going to be beta amino acid. They are monomer of proteins. That is why we are studying this. Okay, like you had glycosidic linkages, here you will have peptide linkages, right? So this is amino acid. Now let us see what is zwitterion. Zwitterion we have studied when there is one basic unit and one acidic unit in one molecule. The base will abstract the acidic, will abstract the H positive from the acid and form the zwitterion here. So here this base has these lone pair. It is going to abstract the H positive to this lone pair, and hence it is going to form, this lone pairs are going to attack on this H positive, and hence it is going to attach H positive here, and it is going to form zwitterion here. Right? This is zwitterion. In zwitterion, amino acids show amphoteric behavior as they react both with acids and with bases, right? Okay, so now here we have we have so many amino acids that you have to remember. I'll write the most important here. Alanine, glycine, very important. Then we have leucine, very important. Isoleucine, again very important. Lysine, very important. Then we have adenine is also very important, right? I think all are important here. So I'll just write the most important here, adenine. Then you have, then you have serine, that is very important for you. Okay, you must not forget about these. Then aspartic acid, glutamic acid is also important, right? Important. Then you have one unit that is, histidine, very important. Okay, then you have phenylalanine, you can easily remember that. Okay, now these are very important for you. Okay, very important units, very important amino acids, right? They can ask you whether it's acidic or basic. They will ask you whether this, for example, you have, what is the structure? This, for example, this is serine. So what is going to be the structure of serine here? It has one OH-CH2 and this side chain is R here. Right now they are going to ask you what is the structure of, let us see they are going to ask you what is the structure of lysine here. Okay, this is the lysine structure. What is the symbol of lysine here? Okay, so these questions are asked in your exams. Okay, what is the structure of lysine, alanine, all these things are asked here in the exam. Right? Okay, this is the R chain here. What is the R chain here? Right? Okay, understood this? Yes, everybody? Okay. Now, just one more thing. That question is not here. Now, they can ask you, lysine is basic or acidic amino acid. So now lysine has more NH2 units here, right? That means it is going to be a basic amino acid, which is an acidic amino acid. You have to know the structures. How many basic unit, how many acidic unit in that. Okay, understood? Yes, beta? Okay, perfect. Now, next is the classification. We have done that according to the number of carboxylic, if number of carboxylic are more, that is acidic. Number of amino group are more, that is basic. Number of amino and carboxylic are same, that is neutral amino acid. Okay. Next we have essential and non-essential. Essential are that are actually not synthesized by our body. Right, we need it from the outside, so that cannot be synthesized in the body. Right, we need it from outside. That are essential amino acid. Non-essential are that are actually synthesized within the body. We can get it from the outside. Even if we don't get it from the outside, they are not needed to our body. Right, this is not a need of the body. That are non-essential amino acid. Now, what is protein? Protein is the where you have, that is actually when amino acids are connected by peptide linkages, right? That is called the protein. The monomer unit here is amino acid, right? Proteins are polymers of alpha amino acid. They are connected to each other by peptide, and always remember this is alpha amino acid, right? You have this COH and this is carbon, this is NH2. This unit is going to be in the protein cells, okay, in the proteins, right? Now let us see what is dipeptide, what is tripeptide. For example, peptide linkage is amide formed between COH group and NH2. Now remember this is a very important point that I'm going to tell you here. In glycosidic linkages, you have ROR group here, right? But you cannot say that glycosidic linkage is ester group, is ether group, right? There is one group here, there is one group here that is combined by one oxygen linkage here. But we cannot say glycosidic is actually ether, right? Why? Because they are not ethers, right? They are just formed by elimination of water by two molecules. Similarly, if we talk about peptide, you have this C, double bond O and NH, right? Something like this. So how it was formed? You had C double bond O, this is OH, this is NH3, right? This is NH, for example, this is N, this is H2, and this is 1H, right? Water will be eliminated, and there will be one amide group. But this amide group, we cannot say this peptide chain is nothing but amide group. No. Peptide chain looks like amide group, but amide group is different and peptide bond is different. Because peptide bond is formed by elimination of water from carboxylic acid and amino group, right? Okay, and NH3 group here, right? Okay, so it will be eliminated and hence you will have CONH bond here, that is peptide linkage. If you have two peptide linkage, dipeptide, 3 we have tripeptide, 4 tetra, and many, then we say it is polypeptide. Okay, now next is there are two types of proteins. Okay, there are two types of proteins. One is fibrous, other is globular. So what is fibrous? What are fibrous and what are globular? Everybody in the comment section. Everybody. We have fibrous and then globular. Okay. Yes. But my beauty is not going to give you numbers. Okay. So please concentrate on this. Right? Okay. Yes. So now we are talking about fibrous and globular. So the fibrous are insoluble in water. Now if you talk about your nails, if you talk about your hairs, it has fibrous units, fibrous proteins. And if you talk about proteins that are actually soluble in water, these are soluble, for example, insulin, albumins, right? This is keratin. Keratin is in hairs, myosin. Okay, these are your fibrous units. Okay, peptide chains held parallel and held together by hydrogen and disulfide bonds. Then fiber, this structure is formed. Okay, the fiber structure is formed. Chains of polypeptide are coiled around to give spherical shape, that are globular protein. This is according to the shape, and what is the function? This is soluble, this is insoluble. Right. Next is the structure of protein. So there are basically four structures. Primary, there are basically three structures: primary, secondary, tertiary. Okay. So this is a primary. It is just the complexity is increasing here. Okay. Primary is like you are zooming in, right? You are zooming into the universe, right? This is the same thing. You are zooming in. Firstly, you will see the primary structure. Here you are actually zooming out. Sorry, not zooming in, zooming out. Okay. So here the primary structure is the linkages of two amino acids, that is peptide linkages, right? That is the linkage of two amino acids, right? That is a primary linkage here, the peptide linkage here between two amino acids. Now, what is the secondary? Okay, this sequence of amino acid, that is said to be primary structure. Each polypeptide in a protein has amino acid linked with each other in a specific sequence, right? Now, what is this? What is this red, green, blue? These defines the different, this red, green, blue are different amino acids here. For example, this is alanine, this is lysine. For example, this is alanine, this is lysine. So this is all different amino acids are linked together by peptide bond here. And that is the primary structure. If we talk about the secondary structure, secondary is just zoom out a little bit. Like what you will see here, how different chains are linked to each other, right? Here you have two types of structure can exist, that is alpha helix and beta plated. Alpha helix is like a spiral kind of thing, okay, a spiral kind of thing. and beta plated is like parallel to each other, right? Okay, so secondary structure arises due to folding backbone of polypeptide chain of hydrogen bond. Alpha helix is like right-handed screw. Okay, this is a spiral kind of thing. Okay, like a snake, right? Next is beta plated structure. Peptide chains are stretched to maximum extension and then joined by intermolecule. Let us see this. Okay, they have not drawn it. Okay, so this is alpha helix and beta plated are something like this. Okay, something like this. Okay, this is beta pleated. This is alpha helix, right? Okay, this is the secondary structure. Tertiary structure is more complexity. Zoom out a little bit. Now what you will see here, how different secondary structures are linked to each other, right? Okay, it represents overall folding of polypeptide, further folding of the secondary structures. How secondary structures are folded, right? It gives rise to two major molecular shape like fibrous and globular here, right? Okay, primary, the linkage of amino acid. Secondary, now how these chains are linked to each other. That can be alpha helix, that is a spiral, that can be beta pleated, right? Third is how these two secondary structures are linked to each other, right? That can be fibrous, that can be globular. They can form a fiber-like structure, hydrogen bonding and sulfide bonds. That can form a globular-like structure, like a globe, right? Okay, two things here. Right, now main forces which stabilizes secondary and tertiary structures protein are hydrogen bonds and disulfide linkages. How they are in 1 degree structure is stabilized by the peptide linkages. The 2 degree and 3 degree structure are stabilized by hydrogen bonding and disulfide bonds, like van der Waals forces, electrostatic forces of attraction, right? These are things that stabilize, that held them together. Now if you denature it, the primary structure is not impacted. Primary structure stays intact. The secondary and tertiary structures goes away, right? But the primary, the peptide linkage, even after denaturation, nothing happens to the primary structure here. This question is asked so many times, right? Okay, now let us see what is quaternary structure. This will also get denatured, right? So quaternary structure is how the tertiary structure are linked to each other, right? Proteins are composed of 2 or more polypeptide chains, therefore to have subunits. The spatial arrangement of these subunits with respect to each other are known as quaternary structures. Further, how they are related to each other, right? The complexity, we are just zooming out, right? If you see from the earth, we are zooming out. You see me, now you see my building, then you see this then you see India, then you see the world, then you see the galaxy, then you see the universe, right? Then you see the Andromeda galaxy, right? Then you see multi-universes, right? The same way we are just getting zoomed out here, okay? We are seeing the macro level here, okay? Understood this? Now, these are the 4 structure. This is the primary amino acids linked to each other. This is beta pleated. This is beta pleated structure. And this is beta pleated, like a wave, beta pleated. This is the first one. This will be the second one. And alpha helix is like this. Alpha helix is like this. Okay. This is the alpha helix. This is like alpha helix. Right? Okay. Right. This is the tertiary. Like you have one. Here what you will see. This is the one unit here. Right. One tertiary structure. Here you have alpha structure here. Here you have alpha structure, here you have secondary structure in between. You will see the secondary structure here, okay, between the tertiary structure. This pipe, you have this pipe, here you will have that alpha helix, right? One amino acid linked to each other, they are linked to alpha helix structure, for example. Then I have this one pipe, okay. For example, a snake is going through the pipe, right? Just imagine a snake going through the pipe. Now the snake, how the snake's skin is linked to each other is the primary structure, right? How the snake skin is linked to each other, that is this is your snake, okay? Now how your snake is dancing or how your snake is walking, that is the alpha helix structure, right? Whether it's like this, whether it's like this, okay? The snake is like this and it is in a pipe. That pipe will be the the tertiary structure. Okay, that pipe is going to be the tertiary, further complexity. Then how so many pipes are linked to each other? This is the first pipe. Okay, this is the second pipe. How they are linked to each other, that is going to be the quaternary structure here. Okay, after denaturation, this secondary, tertiary and quaternary loses its identity, but primary remains the same here. Okay, primary remains the same here. Yes, everyone? Okay. Yes. Snake in the pipe. How you will remember? Primary, secondary, snake in the pipe. And so many pipes are, are messed up with each other, linked to each other. That is the quaternary structure. Okay? Yes, everyone? Okay, perfect. Perfect. Now you know that what is primary, secondary, tertiary, quaternary. Yes, bacha, vitamins. We are going to complete vitamins after RNA, DNA. Okay? We are going to complete vitamins after RNA, DNA. Yes? Okay? Then there is nucleic structure here. Now you have nucleic acid. Now nucleic acid are basically, very important thing. RNA, DNA. What is RNA? What is DNA? RNA, you have ribose sugar. This is you have deoxyribose sugar. And there will be one oxygen less here. Right? Okay, I'll see. We will see this simply. It has basically 3 units here. Okay. This RNA, DNA has 3 units. One is it has which glucose here. Right? Here you have the sugar. The sugar in RNA is ribose and the sugar is DNA is deoxyribose. That means at second position, if we talk about the second position, there will be both hydrogens here. Okay, but in ribose you have one H and one you have OH. Okay, this is deoxy, this is oxy. This is ribose, this is deoxyribose. Okay, so this is the difference between the sugar. Second is the base units here. What will do in the base units here? And what is going to be the phosphor group here. Okay, what is going to be a phosphor unit here. Right, these are the 3 differences. We will see different bases here. We will see different phosphor group here. Right, okay, sugar is in RNA you have ribose, in DNA you have deoxyribose. Okay, so now let us see the units here. Okay, now this is beta D ribose and this is beta deoxyribose. What you will see, at second position you have both hydrogens here, and here at second position you have OH and H. Right, at second position just draw the ribose sugar. Okay, this is the ribose sugar. Draw the ribose sugar, and if you eliminate the oxygen on the second position, that will be deoxyribose. That is the difference in sugar of DNA and RNA. Next is what is nucleotide and what is nucleoside. Now this difference is also important if you are preparing for board examination. This is asked so many times. So now nucleoside is when you have base plus sugar. That is nucleoside. Okay, that means you are just thinking about base and the sugar. Which base is there, which sugar is there. I told you there are 3 parts. One is base, then there is sugar, then there is phosphate. Right? If you are not talking about the phosphate group here, that will be you're talking about the nucleoside. If you are talking about the phosphate linkage also, that will be nucleotide. That is the difference here. Okay, here you have base plus sugar, here you have just base plus sugar plus phosphate. Right? Okay, this is just in terms of talking what we are thinking about. Right? Okay, so now basically we have talked about sugar in RNA, DNA. Let us talk about the phosphate groups here. What are the kind of phosphate group that you can see here? Okay, there can be phosphoric acid, there can be phosphomonoester, there can be other phosphodiester, phosphotriester. So these are all the phosphate groups that you can see in your RNA and DNA. Right? All the phosphate groups. Right. Next is, if we talk about the bases here, we are going to talk about the bases here. Right? There are 3 things. One is sugar, either it can be ribose or deoxyribose, RNA ribose, DNA deoxyribose. There can be different phosphate group. If you are talking about base plus sugar plus phosphate group, that is nucleotide. Right? If you are talking about just base and sugar, that is nucleoside. Right? How many phosphate group? These many phosphate group it can have. Right? Okay. Usually question is asked from the bases, nitrogen bases here. Right? How many nitrogen bases? The basic unit here is that it will be either purine or either it can be pyrimidine. Right? There can be purine or it can be pyrimidine. Right? So this is pyrimidine, this is purine. Different substituents will be there. Right? And we will have different bases here. We will have different bases here. That is adenine, guanine, cytosine, thymine, uracil. These are the 5 most important bases. This is G, this is C, this is U, and this is T. There is also difference in bases also, right? There is also difference in bases. Because these bases are actually hydrogen bonded to each other. You know, DNA is double helix structure. That means 2 helix are interconnected to each other. They are interconnected by hydrogen bonds here. And that hydrogen bonds are formed between the bases. That is why the knowledge of bases is very important for you. We have basically 5 kind of bases. This is purine, and this is pyrimidine. Okay, these all are derivatives of pyrimidine, and these are derivatives of purine, right? Okay, so now everybody always remember this thing. One derivative of pyrimidine will be hydrogen bonded with one derivative of purine, right? Okay, that means A will have hydrogen bonding with T and G will have hydrogen bonding with C, or A will have hydrogen bonding with U. Okay, understood this? A will have hydrogen bonding with T or U, and G will have hydrogen bonding with C. This is how it is going to be this is the combination. This is the combination of hydrogen bonding. These are the combination that you will see here, right? Okay, so let us see this. RNA and DNA. Now in DNA, you do not have uracil here. In DNA, you do not have uracil. In RNA, you have uracil. That means here we have AG. Here you have 2 kind of bondings, that is AT and GC. And here you have AT. Here you have AU. Here you have AU and GC. Okay. These are the 2 combinations for RNA and DNA. Yes, these are the 2 combinations. Okay, bacha. Kindly keep your baseless doubts to yourself. Let this class. Very good, Ruchin. What is happening here? Please tell me your name. Please don't. Fan page, I am going to block you now. This is enough. Okay. Enough is enough. Okay. Don't do. Students have their exams. Don't do this. Okay. So I am going to block you now. So let us block Mr. Fan page. This kind of behavior is not accepted in the class, okay? Okay guys, so I think now this person is not going to disturb us. Okay, everybody back to the class, everybody. Yes. No bacha, no break now. We have exams, okay? No break now. Okay, even I am not feeling like giving you break. Let us not have any break because this is so less chapter is left here. We have completed most of the chapter, then why to take break here? Okay, what's the need of taking break here? You have DNA, we have AT and GC combination. In RNA, you have AU and GC combination. Right? Okay, bacha. Okay, we have 2 combinations, AT, AU. Okay, in RNA, you have uracil in place of thymine. Always there is hydrogen bonding between one pyrimidine and one purine unit. Right? Okay. Right? These are the combination that you have to remember. AT, GC, AU. Right? A is linked to either T or U. T is in DNA and U is in RNA. GC. Okay, girls call it GC. Always remember Girls College, GC. Okay. I am at GC. Okay, everybody will remember what? At GC. At GC. At Girls College. Okay. Okay, Girls College, at Government College. I want to take admission in Government College. At Government College. So this will be A with T. Okay. Then G with C. Okay. G with C. And this is for DNA. This is for DNA. And for RNA, it is A, U, and this is G, C. This is for RNA. Okay, understood this? Government College. Yes. This is interesting chapter. It is interesting chapter. This is actually interesting chapter. Okay, this is ATGC. Right? Okay, just remember these bondings. So now, ma'am, how these bondings are actually done here? How actually this, oh my god, I love this structure. I am totally in love with this structure, okay? I totally love this. You know, you guys are so lucky. You are, you are going to study biology about our body in so much detail. So this is the structure of DNA. So basically this is alpha. There are two alpha here. This is the first alpha here. This is the first alpha helix here. This is another alpha helix here. So this is how it is linked to each other. For example, let me see if I have any prop here in this class. If I have any prop here. Yes, we have a prop, bacha. We have a prop. Okay, we are very jugadu. Now, what is jugadu called in English? Everybody tell me what is jugadu called in English. Okay, we have one jugadu thing here. Okay, so this is the structure. So now, let's see. For example, this is a one alpha structure. What is alpha helix? It is something like this. Okay, it is something like this. It is something that is actually connected like this. Okay, it is something like this. Like if I have this one, it is connected like this. Okay, it is connected like this. This is the alpha helix here. Now, if I talk about two alpha helix here, okay, this is the first alpha helix. It is connected in a very snaky manner. It will be connected in a very snaky manner here. Okay. Okay. Let me connect it like this. Okay, there will be one alpha helix here. And the other alpha helix will be, like if we talk about this one, if we just remove my hand from here, this is the structure. I'm not able to draw the structure here with my hands. Obviously, I'm not able to draw it, right? So this trick is actually now useless. But you can see this. Now this is basically the alpha helix here. If I say there are two alpha helix units, if I zoom this in, so there are two alpha helix units. This is the one alpha helix, this is the second alpha helix. They are actually connected to each other, right? This is the one alpha helix. This is the one alpha helix that is going something like this. Okay, this is going something like this. This is the first part. It is going something like this. This is the first part. It is going something like this. Okay, it is going something like this. I'm going to draw it here because I find this very interesting. Okay, this is the first part here. Right? Or you can draw it like this. In 3D, you can draw it like this. Okay, this is the first part, right? And the second part here. This is double alpha helix. This will go something like this. Okay, this will go something like this. Okay, it will go something like this. So now we have double alpha helix structure. Now these two alpha helix structure are actually hydrogen bonded with each other. They actually have hydrogen bond with each other. Right? They have hydrogen bond with each other. Now this hydrogen bond that I am drawing by this blue pen, this hydrogen bond, for example, I am drawing this in a straight way, right? This is the one, this is the other alpha helix. So they are actually hydrogen bonded to each other, right? So how they are hydrogen bonded to each other? If we are talking about RNA, that will be hydrogen bonded by AU and GC here, and DNA will be AT and GC here, right? Okay, let us see this structure. So for example, you have this G here, this is the G, this is, for example, this is A, right? And this is T here, right? This is A, this is T, right? Here again we have this is A, this is T, right? Again you have this is A, this is, if this is A, this is T, again this is red, this is blue. For example, I am representing if I am representing red as A and blue as T, okay, so there are going to be units like this, and they will be hydrogen bonded here. There will be hydrogen bondings here. There will be hydrogen bondings here, and that is how these bases are linked to each other, giving it a double alpha helix structure. Okay, giving it a double alpha helix structure, right? Okay, okay, bacha. So now DNA is known to be double alpha helix structure. Two helix are hydrogen bonded by hydrogen bonds between them. Now, how the sugar? Now this is very important line everyone, right? Very important, right? Now sugar and phospho groups appear to form rails and the bases appear to form rungs. Now let us see this. Sugar and phospho, right? If we talk about appears to form rails, rails means these are the rails, okay? These are the rails. Rails are what? If you're taking stairs, okay? The steps are called rungs. Okay, the steps are called rungs, and the side lines which you hold, that are called rails. So rails are formed by the sugar. This is the sugar group, this is the phosphate group. This is the sugar group, this is the phosphate group. So the side lines, the rails are formed by sugar and phosphate group, but the steps are formed by the bases here with hydrogen bonding here, right? Okay, appear to be rungs, right? These appear to be, for example, this is a stair here, these are the stair here, right? Okay, this is how they have, given you an example of this, right? Okay, for example, these are the rails and these are the steps here. These are the steps here. The blue part is the steps here, that is rungs, and the green and the white part are the rails here, which have sugar and phosphate group here, right? Okay, everybody? Yes. Okay. Now, next is the structure of RNA. The structure of RNA, we have primary, secondary and tertiary structure here, right? So primary structure is, everyone, what is the primary structure here, everyone? So in the secondary structure, okay, so primary structure is the bonding between one group to the other, right? Between one sugar to phosphate group and then to the base, that is the primary. Then secondary structure, how they are linked to each other. There is one alpha helix and one beta helix. Alpha helix is right-handed helix and beta helix is left-handed helix. This is the alpha helix, this is the beta helix. Okay, if it is going spiral like this, that is alpha. If it is going spiral like this, that is beta. Okay, it is just a deviation of how they are getting spiral formation, right? Alpha helix and beta. Tertiary, when single strand may rewind over itself. When single strand is actually overlapping, that is called tertiary structure of RNA. Next, there are three types of RNA, that is messenger RNA, then we have ribosomal RNA, then we have transfer RNA. They just ask you about the types of RNA here, right? RNA molecules are of three types and perform different functions: messenger, ribosyl, and then transfer RNA. Then we have complementary bases. Like we know complementary bases, add, government, college, right? This is for DNA. Complementary bases for RNA, right? Now let us see how they are actually hydrogen bonded. For example, you have adenine unit paired with thymine or uracil, right? There will be two hydrogen bonds, and everybody, they can also ask you one more thing, okay? AT has 2 hydrogen bonds, AU has 2 hydrogen bonds. Okay, AT or AU has 2 hydrogen bonds, and GC has 3 hydrogen bonds. This question can be directly asked in your exams. Okay, how many hydrogen bonds units are there in AT or EU or AGC or GC? Right, it has 3 hydrogen bonds units in GC. Right? Okay. Cytosine is always paired with guanine and vice versa. Then thymine is always paired with adenine and vice versa. Right? Okay? Perfect. Next, see, you can see the structure of RNA and DNA here. Everybody, in RNA, this is the RNA unit, this is the DNA unit. RNA, you have cytosine, guanine, adenine, and then uracil. Here, in spite of uracil, you have thymine. Right? Okay? So, this is how they are linked to it. This is the single strand here, this is the double strand. Okay, this is the one strand alpha helix, second alpha helix bonded to each other with the hydrogen bonds here. It bonded to each other with the hydrogen bonds here. Right, everybody? Okay. Okay, bacha. Yes, bacha. It is. Yes, very good. Very good. Next we have vitamins. Okay. Next we have vitamins. Now, we are just about to finish this chapter. Now, what is vitamins? This is all theoretical thing. You just need to know the what are the weaknesses that you will get because of some vitamins here, right? So, for example, some organic compounds required in small amounts in our diet, but the deficiency causes specific diseases. There are so many vitamins here. Firstly, we should know what are the fat soluble vitamin and what are the water soluble vitamin. Okay, so these questions are asked in your exam. What are fat soluble vitamin and what are vitamin soluble? What are fat soluble vitamin? Fat soluble vitamin are KEDA. Okay, KEDA. Okay. Okay, KEDA, Keda. What is that? Keda. Okay, Keda is fat soluble. KEDA are fat soluble vitamins which are soluble in fats and oils that are fat soluble in the water are kept in these groups, but insoluble in water. They are stored in liver and adipose fat storing tissues, right? And what are water soluble? Except for this, everything else is fat soluble. Okay, so vitamin water soluble, vitamin which are soluble in water but insoluble in fat are kept in this. They are readily excreted in this. Now this example here is very important. Now here they can readily excreted in urine and cannot be stored in our body because they are water soluble. They will be extracted out because of by the urine, by passing urine. But here also one exception is there, that is vitamin B12. That is a water soluble that will be stored in our body. That is, we can store vitamin B12 in our body. That is the exception here, from where question can be asked. Right? So these are the diseases that you will get. This is vitamin A. You will get xerophthalmia, okay, hardening of cornea of eye because of this, right, eyesight and all that, right? We have heard about that in our earlier classes also. This is very easy. Like vitamin B1 is very. B2 is Cellulose. Now these questions are asked in your previous year exams. Vitamin B6 deficiency causes convulsions. B12 deficiency, that causes pernicious anemia. Now iron is actually, how this is happening, because you know what, anemia is nothing but this is the when you don't have that much hemoglobin, right? So vitamin B12 is responsible for absorption of that. Okay, so it forms because of that RBC deficient in hemoglobin, right? We know that how vitamin B12 is responsible. There are some vitamins that are important for us because they help in digestion or the absorption of some other thing. Like B12 is responsible for hemoglobin, right? If there is less vitamin B12, there will be less hemoglobin, that will lead to anemia, right? Okay, yes. Next is vitamin C, vitamin D, vitamin E, vitamin K, all these things. Okay, what are the deficiency diseases here, right? How you can get it, from where you can get it. So you guys are going to be doctors, so you must already know these things. Okay, these are very easy for you. Now next is hormones. hormones that are in our body. So what kind of hormones we have in our body? Hormones are molecules that act as intercellular messages. Okay, they transfer the messages. They're produced by endocrine glands, which are very important. They're produced by endocrine in the body and are poured directly in the bloodstream, which transfers to site of action. Right? They are actually formed by endocrine gland. Okay, this is main point. They help in maintain the balance of biological activity in the body. Right, there are few examples of hormones here. What insulin gives, it is of this function. This helps in insulin is released to response of rapid rise in the blood glucose level. Sugar is directly related to insulin here. Right, so this is actually, yes. Okay, then we have glycogen. Glycogen, it tends to increase the glucose level in the blood. It increases the glucose level. There are applications. Epinephrine and neuropinephrine. Okay, so they mediate responses to external stimuli. Growth hormone, they're responsible for growth. Thyroxine, this is responsible for thyroid gland, right, to produce in the thyroid gland. It is iodinated derivative of amino acid thyroxine. Abnormally low level of this leads to the which are characterized by, okay, so all these things, you know that what is thyroid and how it is done. All these things are totally theory based things, right? Okay, what are the diseases that will be caused by this and this hormone, everything. This is totally theory based thing. Okay, totally from your NCERT lines. Next is steroid hormones. What are the function of steroid hormones? Adrenaline hormones, diseases, all these things are theoretical things. Okay, I think you will be able to do this on your own. Yes. Chemical control and coordination is my favorite chapter. So everybody, I heard that you have already a chapter on hormones. So I don't think so I need to teach you this, right? Because you already have a full-fledged chapter in biology, right? So you know more than me, right? When we pronounce neo, okay, yeah, maybe I am not good with biology. I have never studied biology, okay? So I am good with chemistry. Biology I studied in 9th and 10th. After that I studied during my masters, because in masters you have some part of these hormones, right? But that was totally structural based. So all these things that are completely bio based things. So I think Baswa sir and Gopika ma'am have already told you all these things. So you must know more than me about these hormones, is it? Yes? Okay, and I'm very bad with biology pronunciation, very bad. That's why I thought of taking non-medical instead of medical, right? Okay, then you have testosterone, estradiol, progesterone, right? Usually students get confused between estradiol and progesterone. Okay, it is a male female sex hormone. It is responsible for development of secondary female characteristics and participates in control of menstrual cycle, right? But progesterone is responsible for preparing the uterus for implantation of fertilized eggs. So there is difference between estradiol and progesterone. Both are female hormones, so but the function is different. Okay, but the function here is different, right? Yes. Okay, so now let us go jump to the PYQs here. Everybody in the chat section, are you all prepared for the PYQs? Yes. Okay, everybody. Now I want all of you to answer the PYQs here. Everyone here, I want all of you to answer the PYQs. Yes, everyone. Norepinephrine. Okay, proper pronunciation. Okay, norepinephrine. Wow, this seems like a German language. Yes. Okay, so now we have next is sucrose on hydrolysis. Okay, I'll see the norepinephrine. Okay, rap is more easy for me than this. Next is sucrose on hydrolysis. It gives what, everybody? Yes, it gives alpha D and beta D glucose, right? Okay, that's the first thing. Next we have the difference between amylose and amylopectin. Everybody, 2018 question. The difference between amylose and amylopectin. Amylopectin have 4 alpha linkage and 1 this linkage. Amylose has 1 this linkage. Amylopectin has this and this linkage. Amylose is made up of glucose and galactose. Everybody, what is the difference here? Yes, okay. What is the difference here? Amylose is just 1 linkage. It is a linear polymer. but amylopectin is a branch polymer. There is 1,6 linkage as well, right? There is 1,6 linkage as well. So that will be A is going to be the first right answer, right? A is going to be the right answer. Yes, very good. Very good. Jeff has answered. Amylose have this. No, beta. Amylose has just one linkage, that is 1 and 4 linkage. But amylopectin is branch, so it will have additional 1,6 linkage here, right? Okay. Next we have the correct corresponding order of names. The correct corresponding order of names of 4 aldose. 2016 question. With configuration, everybody. With configuration. Very simple question, everybody. So now, if we talk about this one, let us see L or D, right? OH on the right side, that is D. This is on the right side, this is D. This is L, this is N. Because on the last chiral carbon, that is this one. This is the last chiral carbon. The OH is on the right or the left side. And on the same side OH, it means it is erythro. It is going to be thereo. It is going to be erythro. It is going to be thereo. So answer this question. ED, 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 ED. So first is DDLL. DDLL, DDLL, DDLL. And this is DD. So A and C cannot be the answer. Then we have erythro-thereo, erythro-thereo, then erythro-thereo. So D is going to be the right answer here, right? D is going to be the right answer here. Because this is D, because OH is on the right side, that means D. You just need to remember this DR, okay? OH is on the right side, that means it is capital D configuration, okay? Erythro means same side, thereo means different side. These are epimers, right? Okay? Yes. Erythro and thereo are epimers to each other. Okay, erythro and thereo are epimers to each other. Erythro you have same side, thereo you have different side. Okay, so D is the right answer. Next is which one? Which one given below is a non-reducing sugar? Which one given below is a non-reducing sugar, everyone? Which one is going to be a non-reducing sugar? Yes, bacha. Yes, everyone here. Which is going to be a non-reducing sugar? Glucose, sucrose, maltose, lactose. Which is going to be a non-reducing sugar? Yes? Okay? Yes, bacha? Everybody? Very good, very good, very good. Sugar. Out of disaccharides, you have sugar, you have sucrose. Sugar, why I'm saying sugar? You have sucrose. That is a non-reducing sugar. So, B is all the other disaccharides are reducing sugars. Okay? Which of the following is basic amino unit? Amino acid. NEET 2020 question. NEET 2020 question. Which of the following is a basic amino acid? Which is a basic amino acid? Serine, alanine, tyrosine, lysine. This is from the chart. Right? From that chart. Right, everybody? Which is going to be the basic amino acid? Everyone here? Everyone here? Very good, very good. Very good, very good. Lysine is going to be the basic. I have specially told you in the chart also, right? That is the PYQ, right? Lysine is the basic unit here. That is the basic unit. This is the R part here. This is the R part here. This is the alkyl chain where we saw that there was one NH2 group here. This is the mean. That is this means that this is the alpha amino acid. It's the alpha amino acid, right? Okay. So, this is it has two NH2 groups here, one COH group here, right? Okay, yes, very good. The non-essential amino acid among the following, which are body do not need from outside, right? Okay, which your body actually generate itself, which is that amino acids that is produced by the body, right? Which is produced by the body, everybody? Yes, bacha, very good, very good. Everybody in the chat box, be a little quick. Alanine, okay, Nancy is saying alanine. Anyone else in the chat box? Yes, bacha. Very good, right? Alanine is the right answer. That is a non-essential, that is actually produced by the body itself, right? Which structure of protein remain intact during denaturation process? Which structure of protein remain intact during the denaturation process? During the denaturation process, secondary, tertiary, quaternary, everything leaves the identity. But there's just one thing, that is primary structure is intact. Okay, primary structure is intact. During denaturation of protein, 2 degree, 3 degree structure is destroyed and 1 degree structure is remained intact. Which of the following compounds can form zwitterion here? Which can amino acids can form zwitterion here? Out of which is amino acid? Out of this, which is an amino acid? This is asked in NEET 2018, a very simple question. Okay, a very simple question. Now, which of the following can form? Which of the following can form zwitterion? Amino acids or something that has a basic and acidic group, right? In just one molecule. Alanine has just basic unit. Acetylene has just one basic unit. Right? Benzoic acid has acidic unit. It has both basic and acidic. Basic and acidic. So that is it is forming zwitterion here. That is D is the right answer. Right? Next is during the process of digestion. Everybody here. Yes, this is from your bio section. Right? 2006 question. Everybody here. Yes. During the process of digestion, the proteins present in food materials are hydrolyzed to amino acids. The two enzymes involved in the process, we have two enzymes that are involved in the process, everyone. We have two enzymes that are involved in the process. Okay? Bacha, soon I am going to teach that. Don't worry. Now, firstly, let's focus on organic. We will complete organic and then we will start with physical. And Nandini ma'am is going to teach you inorganic, right? Okay, because your syllabus is lagging behind, so we just want to push the syllabus here, right? So don't worry, your syllabus will be done and that will be completed in detail, right? In detail that will be completed, right? Okay, yes. So bacha, what is the right answer here? During the process proteins, which enzyme this polypeptide, then enzyme B gives amino acids. Okay, so what are the two enzymes here? Proteins to polypeptides and then polypeptides to amino acids. That means you are just breaking this up, right? You're just breaking this. Okay, so what are these? This is pepsin and trypsin. Okay, trypsin, pepsin and trypsin, right? Okay, next you have protein, pepsin, polypeptide, then trypsin, that is amino acids. Okay, enzymes are made up of, enzymes are made up of edible proteins, proteins with specific structure, nitrogen containing carbohydrates. Okay, enzymes are made up of edible proteins, proteins with specific structure, nitrogen containing, this is 2002 question, nitrogen containing carbohydrates. Yes everyone, very good. Enzymes are made with proteins with specific structure, right? These are your enzymes that are actually natural catalysts, right? Next is, which of the following is correct? 2001 question. Cycloheptane is an aromatic compound. Okay, diastase is an enzyme. Yes, obviously. Okay, which of the following is correct? Acetophenol is an ether. Acetophenol is an ether. Everybody in the comment section. Which of the following is correct? Yes. Even if you don't know that diastase is an enzyme or not, you know that acetophenol is not an ether. You know that cycloheptane is not aromatic. So obviously this is going to be the correct answer, right? Okay, this is going to be the correct answer, right? As enzyme that hydrolyzes starch into maltose, okay? Starch into maltose. Next is deficiency of B1 causes. B1 causes which disease? Deficiency of B1 causes which disease? It causes, bacha here, beriberi, okay? Beriberi disease it causes. So other deficiency, we have done the table part here. Just remember that table of diseases, the deficiencies, right? Okay. Next is, which of the following is not fat soluble? which is not fat soluble, everyone? Which of the following is not fat soluble? Everyone here, which is not fat soluble? You have vitamin B complex, vitamin D complex, vitamin E complex, vitamin A complex. Which is not fat soluble? Keeda is KEDA is fat soluble. Vitamin B complex is not fat soluble. Right? So A is going to be the right answer because Keeda is fat soluble. Is fat soluble. Okay? Rest are fat insoluble. Right? Next is which of the following vitamins is water soluble? Keeda is fat soluble. Right? That is going to be same question but with different meaning. This is 2007 question and this is 2011 question. Same question but just the way of asking the question is different. Right? Okay? Right? That is D is the correct answer here. Next is the central dogma of molecular genetics states that the genetic information flows from. Everyone, this is your question. Right? This is your bio students, you my future doctors. Right? You know this. Okay? Everybody who has no idea about the chemistry, you should know this question because you are going to be future doctors. Right? What is the criteria? Amino acids, protein, DNA, carbohydrates, protein, DNA, RNA, proteins, DNA, RNA, carbohydrates. What is the structure here? What is how the genetic information is transferred? Right, everyone? How it is transferred? Everyone? DNA, then RNA, then we have proteins here. Right? This is how genetic information is transferred. Transcription, and this is called translation. Right? From DNA to RNA is transcription. RNA to proteins is translation. Right? Okay? Next is the correct order. 2017 question. RNA and DNA respectively are. The correct statement, okay? The sugar component in DNA is arabinose and the sugar component in DNA is ribinose, okay? The sugar component R is a 2-deoxyribose and this is the sugar component is arabinose, okay? This is RNA is this and this is the sugar component is RNA is ribose and in DNA is 2-deoxyribose. Yes, D is going to be the right answer here. Next is which of the following statement is not true? Which is not true? Ovalbumin is a simple food reserve in egg white. Okay, right. Blood proteins, thrombin and fibrin, don't go by my pronunciation here. Fibrinogen are involved in blood clotting. Denaturation make protein more active. Insulin maintains sugar level in the blood of the human body. Right? Which of the following they are saying is not correct. Incorrect. Okay? Which of the following is not correct? Yes, bacha. Which of the following is not correct here? Right? Everyone here? Yes. Thank you from me because made organic chemistry easy. Sample user cells are directly going to the brain. Thank you so much, bacha. Thank you so much. And also on Saturday, I am going to conduct the whole class 12 chemistry marathon here. Okay, so everybody also join that session. That is going to be a crisp session, a very crisp and very, revision oriented session that is going to be. Okay, we will get all the points down there. Okay, so everybody do join that session. So what is this? Everybody, yes. Okay, denaturation make the protein more active is wrong. Okay, we are denaturing the protein. Right, that is making the protein more inactive. Right, this is the white part. Okay, this is the white part of the egg. Right, that is albumin is a simple food reserve in egg white. Right, the white part of the egg. Right, the blood proteins and thrombin and fibrinogen are involved in blood clotting that we have done in the deficiency of vitamins. Right, insulin maintains the sugar level. This everybody knows. Okay, right, everybody right now has sugar, so this everybody knows, unfortunately. Now, which of the following hormones is produced under the condition of stress which stimulate glycogenesis in the liver of human beings? Which of the following hormones is responsible for that? right? Conditions of stress, everybody. Conditions of stress. What do you say in conditions of stress? Thyroxine, insulin, adrenaline or estradiol. Which hormone is very good? You say, oh my god, my adrenaline level is so high, right? What do you say? Oh my god, my stress level is so high, right? Right? So C is the right answer. Next, helps in release fatty acids from the fat, and this is under the condition of stress, and it is called flight or fight hormone, right? Fight or flight hormone. Which of the following hormones contain iodine? Which of the following contains iodine? Testosterone, adrenaline, or thyroxine, or insulin? Which contains iodine? Iodine here, right? Everybody, which contains iodine here? 2009 question. Which contains iodine here, bacha? Which contains iodine? Yes, very good. Okay, that is thyroxine contains iodine here, right? Okay, thyroxine hormone contains iodine here. Next is, this is the structure of thyroxine. Next is glycogen is branched chain polymer of alpha this units which are formed by this and this glycosidic linkage, whereas branching occurs in the formation of there is another branching. That structure is called, okay, glycogen is branched chain polymer of this and this unit, whereas branching occurs by the formation of C166 glycosidic linkage. Structure of glycogen is similar to which one? Glycogen has more branching as compared to, very good. The correct answer here is B, amylopectin. The branching, there is difference in the branching. Amylopectin has less branching. Glycogen has more branching, right? Otherwise, the structure is similar to the amylopectin, right? The structure is similar. There is just more complex branching in case of glycogen. Next is, which of the following polymer is stored in the liver of animals? Which is stored in the liver of animals? Everybody, which is stored in liver of animals? Animals. Okay, in liver of animals, which is stored? Right? Amylose, glucose, amylopectin, glycogen. Which is stored in? Yes. Okay, which is stored in? That is glycogen. Cellulose is plant. Right? This is animal. Right? In liver and all. Right? This is animals, stored in animals. Right? This is converted into glucose when we are in lack of energy. Right? That is converted into glucose. Glycogen is polymer of alpha-D-glucose stored in the liver, brain and muscles of animals known as animal starch. This is called animal starch. Okay? Animal starch. Which of the following pair represents anomers? Now what is anomers? That are cyclic anomers. Last chiral carbon. Okay? There's difference in that. Okay, which of the following is anomer, 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 anomer. All the positions here are different, same except for one first carbon. Right? So here we have different carbon. Right? Here we have different, but all other positions here are, but this is cyclic. Okay, they're talking about anomers, no? So this is epimer, this is not anomer. Anomer, this is anomer, right? Okay, this is also not cyclic. This is cyclic, but there is difference in first position. There is difference in second position as well. There should be difference in only carbon number 1. There should be difference in carbon number 1, different. Carbon number 1, different. And also then you will write cyclic epimer. Cyclic epimer are anomers. Anomers. Okay. So now these are epimers. These are epimers. Okay. This is epimer. This is epimer, not anomer. This is H. This is H and this is OH. This is OH and this is H. This is not even epimer. Not epimer. This is not epimer. Because there is difference in other carbons also. There should be difference in only just one carbon here. Right? Okay. And here also there is difference in 2 carbons here. Right? 3 carbons. 4 carbons. No, not at all. Not epimers, not anomers. Not epimers, not anomers. Right? Okay, these are anomers. That is C is going to be the right answer here. Yes, everyone. Okay, C is going to be the. Why are you deleting your messages? What happened? Okay, C is the right answer. Yes, everyone. Which of the following acids is a vitamin? Which of the following acid is a vitamin? Aspartic acid, ascorbic acid, adipic acid, saccharic acid. Everyone here. Which of the following acid is a vitamin? Which is a vitamin? Everybody. Which is a vitamin? Yes. Very good. Which is a vitamin? Aspartic acid, ascorbic acid, adipic acid, saccharic acid. Right? Okay? Yes. Ascorbic acid is the vitamin here. Very good. Ascorbic acid is the vitamin here. Right? Is the chemical name of vitamin C. While others are not vitamin, aspartic acid is amino acid. Adipic acid is dicarboxylic acid. Saccharic acid is dicarboxylic acid with oxidation of glucose. Under this is this. Okay. So out of this ascorbic acid is vitamin C. Right? Okay. Next is which of the following structure is not true? Is not true about the glucose. It is an aldohexose. On heating with HI it forms N-hexane. It is present in furanose form. It does not give 2,4-DNP test. Yes, everyone. Which of the following is not true about glucose? Which is not true? Which is not true? Not true. Incorrect. Okay. Okay. Which is not true here? Incorrect here. B, D, C. Good. Very good. Very good. It gives pyranose form. Okay. It is not in furanose form. It is in pyranose form. So this is incorrect. Yes, it is an aldohexose. Yes. It is at 6 carbons. It is a carbohydrate. It has 6 carbon. It has aldehyde group. And it is aldohexose. On heating with HI, it gives N-hexane. It does not give 2,4-DNP test. That is why we eliminated the open chain structure here. Right? Okay. So C is the correct answer. Each polypeptide protein has amino acid linked with each other. Right? Each polypeptide in the protein has amino acid linked with each other in a specific sequence of amino acid is said to be. Everybody, the sequence of amino acid is said to be primary structure, secondary structure, tertiary, quaternary. Right? Which structure is that? Yes, fructose is present in furanose form. Yes, fructose is present in furanose form. Yes, very good. Okay. Amino acids are connected to each other with peptide bond. That is the primary structure. Okay, that is not the quaternary structure. Okay, beta, that is a primary structure. DNA, RNA contain 4 bases. At which of the following bases not present in RNA? RNA, which RNA, okay, which is not present in RNA. Everybody, there is a replacement of one base here, right? What is that base? At Government College is for DNA. T is replaced by U, okay, T is replaced by U, okay, which is not present in RNA. This thymine is not present in RNA. It has G linked with C. It has A linked with U. Right? Right? Okay? Yes. That is thymine is not present. Very good. Next is which of the following reaction of glucose can be explained by its cyclic structure? Right? Which can be explained? Glucose form pentaacetate. Can this be explained? Glucose reacts with which of the following can be explained? Glucose react with hydroxylamine to form oxide. Pentaacetate glucose does not react with this. Glucose is oxidized by nitric acid to gluconic acid. Everybody? Which of the following can be explained? Can be explained, okay? Everybody? Yes, bacha. Okay, perfect, perfect. A, C, A, C, A, C, A, C. Pentaacetate of glucose does not react with hydroxylamine. See, glucose form pentaacetate, we have found that in open chain structure as well. Right? Glucose react with hydroxylamine to oxime? Yes, it does. Glucose is oxidized by nitric acid. These all structure we have done in open chain structure. But pentaacetate of glucose does not react with hydroxylamine. This was not explained by the open chain structure. Okay? So therefore that we will have to have the cyclic acid, cyclic structure here. Right? Okay? Okay? That is pentaacetate of glucose does not react. Why? Because of no free CHO group. Right? That is explained because of this. Because of no CHO group, this pentaacetate does not react with hydroxylamine, because in the cyclic structure you do not have any free CHO groups here. Right? Okay? Yes. Then you have which of the following B group vitamins can be stored in our body except for one. Okay? Except for one, all others, vitamin B will be urinated out from the body. That one exception, what is that? Yes, pick. What is that exception? Everybody in the chat box, that exception is very good. That exception here is B, very good. B12 here. Right? B12 with that exception. All the other except, okay, Kida is fat soluble. All others are water soluble means that will be excreted out through urination, right? But there is one that is B12 not excreted out, that is stored in our body, stored in body, okay, except for B12. Okay, all others are urinated, excreted out of the body, but this is stored in our body. Okay, yes, perfect. Next is optical rotation of some compounds along with their structures are given below. Which of the following have D configuration? Now, which has capital D? Capital D has no relation with dextro or levorotatory, that is small d or small l. No relation here, right? We're talking about this one. Here you have last chiral carbon, OH group is present on the right side. It is capital D. OH group is on the right side, that is capital D. OH group is on the right side, that is capital D. Right? No relation. Student usually confuses. Okay, this is plus, this is small capital T, this is plus, this is capital T, this is minus, this is capital L. Right? This is small d, this is small d, and this is small l. Okay, because of the rotation here. Right? Below, which of them have D configuration? All these have D configuration. Right? So 1, 2, 3 have D configuration. So answer will be A. Right? Okay? Understood this, everybody? Yes. So bacha, we have completed this chapter and you will get your handwritten notes. But before that, just one thing for you. That is not specially for you. That is our crash course. That is just for 4,000. Okay, that is just for 4,000. That is the price now. Okay, that is the price now, and that is starting on 26th of Feb. Okay, on 26th of Feb that is starting. So hurry up, enroll yourself in this batch. Right? So this is going to be English where 27 FLTs, 50 part tests, regular test analysis, and weaknesses identification. Now, you know what? This is much needed for you in 2 months. Right? This is much needed for you in 2 months. Right? So everybody, if you're not like face-to-face mentorship, everything, personal mentorship, everything will be provided to you in this. Right? So next is, now one more thing here, how you can get enrolled to the batch here. Okay. So, wait. This is the, you will see NEET 2024 crash course, right? This is the link here. Just go through this link. Okay, go through this link and you will get the, you will be get to this course, right? So view course plans. This is 4,000 for 3 months, right? Okay, 4,000 for 3 months. That's a big deal, right? Okay, you just need to buy full course here, get yourself enrolled here, right? Now, next thing is that how you will get these notes. Okay, how you will get these notes. So everybody here, I hope so all of you are on the Telegram channel. I hope so all of you are on the Telegram channel. So on the Telegram channel, I am going to give you one link by tomorrow's evening, like 5 p.m. Before 5 p.m. I am going to give you, before 5 or let's say 6 p.m. okay, before 6 p.m. I am going to give you the notes here, okay, my own handwritten notes with the tricks of biomolecules. That all I have written here for your short quick revision. Okay, all these notes will be provided to you on the Telegram channel so that it will be easy for you. You just need to do one thing, take out the printouts. Okay, take out the printouts of that and then study it. If you don't want to take the printouts, just study this on the phone or on your laptop, right? You will get the link on the Telegram channel, for the notes here. Okay, everybody? Yes, you will get it by tomorrow. Now, how you can join to the Telegram channel? Here you will get the join Telegram channel for all the sessions, right? Just join this Telegram channel here. Okay, join the Telegram channel here. Right, everybody? So this is the Telegram channel. Yes. Okay, this is the Telegram channel here. Right? Okay. Next we have treasure box for all the students who are right now preparing for NEET, who are droppers. Just listen to this very carefully. You need to do the PYQs test for this. For example, let us come to chemistry. Then let us see the biomolecules part here. This is the NEET link here. Notes will be updated here. Corresponding to this, you have NCERT quick test here, right? PYQs test here. Now, get enrolled to the test here. This is totally free of cost. Just give this test, okay? Give this test. These are the tests for your PYQs. Next is for your CBSE questions. All the students who are preparing for CBSE class 12, right? Go through this. These are the CBSE answers. These are CBSE PYQs. Okay, these are the CBSE PYQs with the solutions. These are the CBSE PYQs with the solution with no error here, right? Next is NEET PYQs. Here you will get the NEET PYQs. Next we have one thing, ma'am, that is NCERT solution. We are also providing you that for totally free of cost. Just go through this. This is the NEET solution, NCERT solution for biomolecules. Okay. Now I want all of you to go through the questions. If you are preparing for class 12th board exam, go through the NCERT questions. Please go through the NCERT questions and then your CBSE PYQs. If you are preparing for NEET, you have to go through CBSE PYQs. You have to go through NCERT question. You have to go through the NEET chapter wise PYQs here. Then give your PYQs test. Right? After that, you will get your handwritten notes. And I want all of you to show the love to the handwritten notes. So that because it takes a lot of hard work to prepare handwritten notes for you. So if I get, if you want more handwritten notes of all the chapters, right, one by one I will provide you the handwritten notes. But here one promise. I want every session you need to comment on yes ma'am. Whenever you get the handwritten notes, you have to go through the link here. On, for example, I'll give you the biomolecules handwritten notes tomorrow. Come to this live, then go through the handwritten notes, write it down. Yes, ma'am, we want handwritten notes for other chapters as well. Okay? Yes, everybody? Yes, everybody? Okay, perfect. Okay then, bacha. Bye-bye. Take care. Have have a sound sleep and take care of your health. All the students who are preparing for CBSE board or droppers, everybody in the comment section write it down that yes ma'am, we are from CBSE, we are from droppers. Okay, one more thing here, that is Vidyagul mock test series. That in Vidyagul mock test series we have total 5 mock tests. One is 11th, one is for full length 12th, and 3 mock tests are for 11th plus 12th. Okay, they have 3 mock tests. One is for 11th, one is for 12th. Okay, then there is one scholarship test. And I advise every one of you to give that test. Okay, that one scholarship test is available, that is IV-SAT test is available here, right? You just need to click on the link here. This is the Biomolecules. Click on the IV-SAT link here. This is the IV-SAT link. Click on this one. Add into your name and what city you belong to, whether you are giving the test offline mode or online mode. If you are giving the test offline mode, you will get 2x amount of scholarship. If online mode, you will get x amount of scholarship depending upon your rank, right? Okay. Next thing, bacha. One thing I forgot to tell you. Very important thing. I totally forgot. You know, very important thing. What is that? I want all of you to give your city names in the chat section. City name in the chat section. Now, what is the reason? Okay, what is the chat section or comments? Okay, I'll see the comments here because I want to meet all of you. So I seriously want to meet you in person. So I want to see from which city you belong to. So I'll try to come to that city where there is majority. Okay, so obviously I cannot come to all the cities one by one, right? Because I have to teach also. So here we will also teach you when we will meet you, right? Okay, but I need to know that my students belong to which city so that I can actually, I will be able to understand that where I should go, right? Okay, everybody? Okay, bacha? Yes. Everybody in the chat box, write down. You have 2-3 tasks to do. First is write down your city in the comment section. Second is, after getting the handwritten notes, I want all of you, go through those handwritten notes. If you like that, do let me know, right? I'll prepare that for more chapters, right? Okay? Yes. Okay then, bye-bye. Take care, bacha. Good night. Have a healthy sleep. Take care. Good night. See you.